The Earth is very flat.
What's going on, everyone? It is Wednesday, June 23rd, 2021. This is Brandon, host of Brandon Show. Hope you guys are doing good tonight or this morning, depending on where you're at. I see in the chat we've got Paul Cruikshank. What's up, man? Gadget Inspector. Good Servant. Hey, Good Servant. Unicorn Laser Eyes. Dan Morris. The Plain Truth. Page 42. Bill G. And I think that's it so far. What's up, guys? Sounds good. Thanks, Bill. And we've got a couple people in Discord. I brought up a video last night. I didn't get a chance to talk about with the sun. We'll probably talk about that tonight. And see what else we got going on. I'll see if anybody wants to talk about rockets in a vacuum, because that came back up today. And I'm getting conflicting stories from the ballers, which is interesting. But we'll see where it goes. First half of the show is going to be flat earthers only. We'll definitely stick to that tonight, and then we'll open it up, and anybody is welcome to come on in. So yeah, let's go. What's up, guys? Hello.
Hello.
Brandon.
There you are.
Brandon, how you doing?
What's up? We've got Aaron, Farming Ganja, Geo, Jeremy, Rob, and Rodney B. What's new, guys?
We're now going to be just listening in.
You're just listening, Rob? Okay. Cool. Well, the first half of the show is flat earth only tonight. And then we'll open it up and let the ballers back in. So we can talk about whatever you guys want to talk about. I've got a video that we can watch about the sun. We didn't get a chance to look at it last night. Well, it's not about the sun. It's about a potentially what's going on with the sun in the atmosphere. But I'll bring that up in a second. Godzilla 37, $5. Just stepped outside to check, and yup, Ranty is still a lying snake. Thank you very much, Godzilla. Appreciate that. Yeah, so anybody got anything they're burning to talk about tonight? Without the ballers on? Or should I show this video? All right, I'll show the video. Let me bring it up here. Damn, this thing's not working. My mouse suddenly decided to stop working. Hold on. It's always something. Let me drag this over and share my screen, or I am sharing my screen. Okay. Can you guys see that?
Yep.
Okay. Now, I don't think anybody's talked about this for quite a while. But I thought it was interesting, and this idea was brought up a long time ago for, how the sun light would illuminate parts of the flat earth and not other parts. So I'll just play it, and then we can talk about it. And talk about if this idea is even worth talking about. I mean, you are putting a big chunk of glass on top of a piece of paper and shining a light into it. I'm not sure how applicable that is to reality. Although you do get some interesting kind of effects there with the light. The coffee cup caustic, I think it's called, where the light kind of curls around and illuminates the other side as well a little bit. Like you can see it over here. It's illuminated a little bit, and it's kind of going all the way around to the back. But this area over here is dark. And this is kind of a curved area that's illuminated, and it changes depending on where that light is above this dome. Oh, I don't know. Could be. I don't know. What do you guys think? Hello?
That's an interesting concept. It'd be cool if you'd have like a little camera inside the glass dome to see what it looks like from the inside.
Yeah, that's an interesting idea. I think this is a piece of solid glass too.
Yeah, it looks solid.
Right. What are these chunks of glass even for? I mean, what is their actual purpose? Why does somebody have like a half ball of glass? Is it like a paperweight, or anybody have any clue?
No clue.
No. Okay.
I mean, if you think about the shit that we're told, we should think that the atmosphere is like a solid piece of glass. So you look at Pink Floyd's Dark Side of the Moon cover, and there's a solitary, singular ray of fucking light that doesn't exist that then spreads into a prism of rainbow. And then we're told, oh, Snell's law. Snell's law, when it comes into a medium that's denser than it, that it takes a different trajectory. And then and you got the theta angle. And look, I've been doing this for 3 years. I've been looking at shit for 3 years. Yeah, if you want to call me out on the fact that I don't have any data for the temperature profile, the barometric profile, yeah, you're right, I don't. But I'm going to tell you that anyone with a basic understanding of reading, who reads the articles that are out there, these guys that were doing these observations in the 1700s weren't looking through a P900. They were looking with their fucking eye. And then making conclusions that they had no way of verifying. So if you want to bitch about the fact that I call the medium the ether band, then you might as well call out Einstein on talking about special relativity, general relativity, because it's a concept. It's an idea, right? So the stuff that you're talking about is really, really interesting. Absolutely. Absolutely. But this is much, much more, it's much more complicated than simply going to a fucking Brandon's show and just yelling at each other, talking about whatever. It's a lot more complicated than that. I'm done.
All right. Yeah, I agree. But I wanted to mention something to you. Last night, I can't remember who it was, but one of the ballers was saying, oh, you just made up the ether band, blah 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 blah. Like the fact that you made up this term to describe what you see nullifies all the observations that you've made over the years. I hope nobody takes that attack seriously, because that's just a ridiculous thing that they attack you with. It's
okay, look, so
nonsense.
think about this. Yeah, sure. That's a fair criticism, right? So instead of just making a claim that I'm just making up the term, who has ever said, okay, look, Travis, let's spend a couple hours on a Saturday or whenever you've got time, we'll talk about this, we'll work through this. No one's ever done that. No one. They've all just said, you're just making this term up. You just want to be famous. You just want people to know, blah, blah, you know. I'm like, no. Look, I'm looking at this. Look, here's a claim for you, right? Okay, if you do any research on this, Andrew Thomas Young, in 2 different articles, states that the mirage the image of the mirage is a vertical image. That is, it's straight up and down. It's like you're looking at a fucking wall. Okay? Now, in my research for the past couple of years, you know, I'm doing stuff on the fly. I'm doing stuff on the fly.
Yeah. Oh, whoever's trying to talk right now is roboting really bad.
Guys are quoting, you're misquoting him, and second of all, he thinks you're all a bunch of idiots. Do you have me, Brandon?
Yeah, you just came in to tell us that Andrew Thomas Young thinks we're all idiots. That's fantastic, Bob. Anyway,
Yeah, you're misquoting.
The fool out of you. Keybrain made a fool out of you, Bob.
Really? When?
Just today, bro.
oh, really?
Just
I didn't
today.
see that.
With that silliness on his stupid animation?
Well, I'm going to allow
Yeah,
this discussion.
That's not even worth the response.
Goodbye, Bob.
Anyway, Bob.
Oh, so anyway, just going back to it. So, you know, the
Okay.
observations that I've made have, you know, I've watched this stuff over and over and over again. I had no I had no prepared expectation for the observations that I was going to make. I'm looking at stuff for the past 3 years completely from ground level and saying, okay, what the hell am I looking at? And the conclusion that I've got right now, that I think is actually a very profound conclusion, is that the image of the mirage extends over the x-axis. It's not a 90-degree angle. It's not a vertical image. And that is what the model of Andrew Thomas Young and others in that analysis puts out. And I'm here to challenge it.
Yeah, I think that's fair. I've learned a lot from your observations and the observations of others, and I think saying you made up the ether band is just a convenient way to dismiss all of the observations that you've made, or anything you've pointed out based on them, and to not have to discuss
Well said.
anything more than boats go over the curve. But getting back to this sun thing, I've never been a proponent of the dome. I don't think that I have any evidence to point to there being a dome unless I, just flat out say, well, there's, gas in the earth, so it has to be contained. That's the only argument for me that really holds any water. I can't think of any others, so I don't talk about it at all.
Unless it's an infinite plane, you're definitely gonna need walls, though. You could argue against a dome, not a dome. Some people think there is, maybe not. You're definitely gonna need container walls for sure.
I would think so. I agree
Unless
with
it's
that.
an infinite plane. Unless it's an infinite plane or some kind of simulation that's being rendered as we go, like a Minecraft world. Shouts out to the real Bob Dole. But, yeah, you're going to need container walls unless it's something like that.
I'm happy to say that I don't know if there's a dome or how we're contained. I'm fine with that. It makes sense to me that there would be walls, obviously, to hold in the gas from just kind of filling up the vacuum that supposedly surrounds us. But I really don't know. But this idea that may be causing the light, I thought was interesting. Causing the light to kind of wrap around like that in that coffee cup caustic would explain some of the observations that we've seen. If there is something with the atmosphere, or something besides just you put a light over a circle Earth and say, oh, see, it doesn't match up. That seems a little too easy and convenient of an analysis to dismiss the idea that the patterns of day and night could fit over a flat plane, especially when we really don't know the dimensions of it unless we take for gospel what the government says. I don't know. Anybody else have any other thoughts on that? No?
Were you talking to me that whole time?
Sort of. I was talking to the people on the call. What's with you guys? What the hell are you guys all doing out there?
I'm at. They got me doing this weird work thing.
So let me kind of take a jump off of what you just talked about, Brandon. I've thought about this not in depth, but just cursory as it comes up. So we talk about spectroscopy, right? We talk about looking at the sun through the filter of the atmosphere, and we see that it resembles the burning of certain elements. Whatever the elements are you want to call. I don't give a shit. Okay. What if the sun, as a source, travels through the elements of our atmosphere? And let's say that there are 7 layers of the atmosphere. Let's say that one of those layers is helium or hydrogen. And the sun that hits that layer produces a certain effect. Is that possible? Okay, hold on. Is it possible? Right? Because if you say no, then you must surely know all of the answers to disqualify my suggestion right now. But if there's a layer of helium, if there's a layer of hydrogen, if there's a layer of nitrogen, if there's a layer of whatever, and the sun, when it interacts with that layer, produces a certain spectroscopy, then the sun isn't then the source of that effect, right? The sun isn't hydrogen burning. It's simply the source that produces the effect through a layer of hydrogen. Just throwing that out there.
That's interesting too, because
don't
I've
forget-
been the sun being a hydrogen and whatever they say it is. There's definitely the heat is based on a reaction, right? It's not like you're getting direct heat from the sun. Just because the light hits you doesn't mean you're going to get hot. For example, at the top of Mount Everest, it's like 29,000 feet up, right? You're closer to the sun, but it doesn't make a lick of difference. It's freezing fucking cold up there. Oh, yeah. I don't know. I'm just thinking out loud, I guess. But it could be, Travis. It could be some interaction. We don't know. We don't know what's going on up there.
And I think the thing with maybe there being this kind of lens that you have to take into account is that maybe the apparent position when we see the sun and the moon is not the true position.
What do you mean? Like it's like projected somehow, or we're just seeing because of
and either projected or just like refracted, like how it would be through a lens. So maybe that's why when you get these observations to the angles of things, you're not really getting the true distances.
Yeah, could be. But I mean, I think there's something more going on with our vision and the way we see across distance too. So I definitely would buy that the sun is where we're seeing it is just an apparent position. Yeah. Anyway. Can you guys hear that vacuum? My wife just decided to run the vacuum. You guys don't hear it?
I hear nothing.
No, we don't. I don't hear it.
Yeah, I was gonna say I didn't want to interrupt it, but I don't hear anything right now.
Oh, okay, cool.
You gotta get a Roomba. Get a Roomba, bro.
A room? You got a Roomba?
I had one that died, but it was a great vacuum, longest lasting vacuum, automatic. All you do is press the button, the shit vacuums the floor. Boom.
That's it, huh?
Yeah.
I'll have to try that. Can it do hardwood floors?
Yeah, it'll help you keep your floor cleaner free of clutter too, because you got to have your, you can't have shit lying all around if you think the Roomba's gonna go around and vacuum. Oh, they got Roomba mops, everything. They got mops, all kinds of shit. Yeah.
Huh.
Jeremy, who are you talking to? I don't see him lighting up.
Brandon.
No, I can't hear Brandon.
You can't hear me?
I hear him fine.
That's
Did you
why
mute him
couldn't
on
hear
accident?
anything.
Weren't you just having a conversation with him?
I know, that's what I'm saying. It's just crazy. He dropped off, and
I'm here.
Did you mute him on accident? Can you hear him now?
I
Hello?
don't even see him on my screen.
I hear you, Brandon. I hear you.
Yeah, I'm definitely here, Travis.
Okay, I got you. That
Oh.
is really weird. Okay,
okay.
you're back. Sorry.
You also.
This is a live show, bro. No, I'm just kidding.
Sorry, Jeremy. I'm sorry.
It's not our best start tonight.
Yeah, good start.
What's that, Bob? You said something?
I can also hear you.
Oh, okay, good. All right.
So if I can hear you, it must be working properly. If someone else has an issue, that's their problem.
Yeah. Fuck them.
Back
Anyways,
off, Bob. Back off, Brandon.
So what?
Back
Anyway, what else is going on? What do you guys want to talk about? It's flat earthers only. Open floor. Come on, say some crazy shit.
All right, let me
some crazy ideas.
let me
out
read
there.
something. Let me read something to you guys. We went out garage sailing the other day, it was a few weeks ago or whatever, and I was looking for old books to kind of see if I could find old encyclopedias and stuff like that. And I found one. I don't know how old it is. Okay, because there's no date in it for whatever reason. Where they normally put the date, like by the copyright and all that stuff, there's no date. I cannot find a date. All I know is that this thing says publisher since 1876, whoever these people are. Okay, but they have this map. They call it Map of the World Polar Projection, okay, azimuthal equidistant projection, okay, and they have the North Pole at the center. And up near the top left, there's this little box. And here's what it says in this box. This map has been prepared with the North Pole as the mathematical center. From it, distances to any part of the world may be measured. On Mercator's map of the world, the polar regions are so scattered that their relatively small area and availability for flight routes are disregarded. Today, with airplanes following great circle courses, often within the Arctic Circle, polar projection maps are indispensable to the people of this air-minded age.
Oh, really? First of all, you went to a garage sale, bought an NES, and now you're playing Duck Hunt in your pajamas. Second of all, yeah, they can't fly without these projections. It's called grid north. North isn't the same for airplanes as it is for there's 4 different types of north, and the airplanes have one of them. It's called grid north.
What is grid north?
Am I coming through?
Yeah.
It's the north they use on projections for airplane routes or some shit. I don't know. I think. I haven't looked at it in a long time. I could be wrong, but I'm pretty sure that's what it is.
Brandon, I got something that might be interesting.
Go for it.
You guys heard about the recent eclipse, the ring?
Yeah, I think you're cutting out a little bit. Yeah, the
Yeah,
clip
they
that just happened?
failed on their prediction. They failed on their prediction. Where was the fucking totality at? They can't show it.
Exactly. There's I've searched around. I've asked people. I search around. Does anybody have a picture, a real life picture of the totality? Excuse me, the ring. Because I haven't. I've filmed it myself. I have the horns. I have a partial eclipse. A good picture, actually, a good video. But I haven't seen any totality. The ring. Has Has anybody seen it?
No, but wasn't it supposed to be in your area?
Yeah,
Like
I got up
Canada,
in the
Afghanistan, a few areas.
Yep, it was up here in the north.
Yep.
But I got the two horns partial. And I've looked, I haven't found any. Maybe I'm just a bad researcher.
There's a video from Cambridge. I'll post it in the chat.
And it has a total ring.
Yeah, I think it happens at 1 hour and 5 minutes in the.
Say again, which can you? If you can post it, that would be good.
I think it's on tonight's Flat Earth debates. I was showing it on, I think it was yesterday on Nathan's show. Somebody said Cambridge University, so it's on there, and they do show it.
Really? You saw it yourself, bro?
No, not personally. I found the yeah, it's on tonight's show. If you go to tonight's Flat Earth debate that's started, it's at the beginning there. You go back to about minus 50, you'll see it now.
Here's the problem with that. It's supposed to be visible through Canada, Greenland, and Russia. If Cambridge got the Ring of Fire, they still falsely predict it. And then what about the eclipse?
No, it's not from Cambridge. It was Cambridge University that had cameras in Canada.
Gotcha.
It was in Canada. Okay, interesting.
Yeah. From my understanding, we kind of, there's a guy in Discord that brought it to the show and brought the video, and then I just brought it up, and because he was hunting for it. Yeah.
Cool. I'd like to see that.
Yeah, because I've seen about 3 or 4 situations where it wasn't lined up. That would be interesting to see one that does line up, but still, I'm still outnumbered at least 3 to 1.
So, SE, you said that it doesn't match the predictions. Are you basing that off the fact that you didn't see the totality, or?
Well, partially. To be fair, where I was, it wasn't supposed to be a totality. So I got what they said, the horns, right? But further north, it was supposed to be the ring, and I haven't seen now. He says he saw it, so that's cool. I'll post what I captured.
I've just posted it in the general chat. The link from Cambridge University Astronomy Department. So
Thanks,
I think,
thanks, Adam.
You go to about 1 hour 5 minutes for a bit. It kind of starts there and transitions through to it. So yeah.
Yep,
cool.
It opened. Wow, that is pretty freaking cool looking. I'll give him that. Look at that thing. And that one in front is supposed to be 93 million miles away from the one in back. Yeah, I'm not buying it.
Yeah, it doesn't prove a heliocentric model. It just proves that what the almanac predicted occurred.
Yeah. It's all
Man,
cyclical, so I would think they'd be pretty good at
Well,
predicting it by now. You know, it's not like it's a surprise each time.
Not at all. We had the Saros cycle, and we had the Antikythera mechanism. Been doing this for thousands of years. This is hardly anything to go, wow.
Yeah, right, exactly.
Yeah, wasn't that USC that pulled up that page, that paper from NASA, showing that they named the guy like George something or another. Where he uses this Saros cycle, and NASA uses this guy strictly uses this guy solely for eclipse predictions, and he's using the Saros cycle.
Yeah, and we've looked into that, and then the thing they always say is, well, it doesn't predict the location because it changes each cycle, which is true, but the change is predictable. So
I was thinking this though, shouldn't the eclipse be shouldn't the maximum eclipse be somewhere around like double the ecliptic? I mean, that's kind of being graceful. It seems like if the sun was completely at one end of the ecliptic and the moon was at the other, if the distance of the sun is so far away, how could it project eclipses all the way up into the upper latitudes? I mean, has anybody looked into that? It doesn't seem like it would have the angle.
no, I haven't.
Brian, I just want to say,
go ahead, Jeremy.
Brian, nice work. No, I just want to tell Brian, nice work on Jose's with that Mary Schweitzer shit and the dinosaur bones, man. They just be making shit up, bro. QE killed him in that numpty clip.
I watched that video last night that someone had posted talking about the stupid soft tissue. Retards.
Who's been bringing?
Yeah, I know, man.
How did that go? Bringing that topic up, was it?
I didn't want to switch topics. Yeah, my bad, guys. Go ahead.
No, that was I know, QE's better versed and everything, and he played the sound effects. It was hilarious. Like, I know he had to be pulling his hair out, and I finally got to the point at the end, man. He had to be pulling his hair out, but that was he was like, finally you get to the. But I was like, you keep calling it fossils, but it's soft tissue and bone. So quit calling it a fossil, man. You're the biologist, But yeah, that made me feel good, man. That was cool. Shout out to QE. Shout out to. Anyway, man, I don't want to lose this topic. Can anybody? This is what I want to see. Okay, to me it seems like the eclipses. Okay, we're predicting them and everything, but so if the heliocentric model, if they want to take credit, I would like to see if they can predict the angle of the eclipse, like the direction the sun, because it seems to go. Like I've seen the shadow come down it and then go back up. I've seen it come from the side and then leave out the bottom left, because I made a false claim talking about the eclipse is always coming in from the toward the top, and I was wrong. So, but I looked into it, and it just seemed like it's coming and going wherever it wants. I want to see somebody from the heliocentric model using their orbits pick the direction of the shadow, the entry direction and the exit direction. I'd be curious to see if that's possible.
Why?
Yeah, we have that on every single eclipse. That's on every single eclipse. You can see exactly how it will cross the path of the sun, or the face of the sun, or the face of the moon.
So if they had just as accurate a model as what we have, which is Rahu and Ketu, to predict these things, does it make it correct? So even if their model, which is more deficient than the kind of flat Earth ancient model at predicting these things, even if they had a model that was equivalent to that, would that validate heliocentrism in any way?
Yes.
Why?
Absolutely.
So they've got a model that's as predictive as the flat Earth model now. Suddenly, that
you don't have a flat Earth model. The Saros cycle. The Saros cycle is absolutely dependent on a detailed knowledge of the orbits of the moon and the Earth, and it also you notice that each cycle, every 18-year cycle, is offset by 8 hours, so it goes 120 degrees around the globe and 300 kilometers north. I mean, that's very, very definitive.
So what? So it's a cycle that offsets a little bit. Who cares?
No, well, it can be explained as the Antikythera mechanism does. You can explain it in orbits like that, or you could also explain it in the way that the mechanism's built, which is one rotation and then a small second rotation built upon that. That's how the Antikythera mechanism predicts these things. So you've got this cog mechanism that predicts it and works exactly, and you've got a heliocentric model that doesn't predict it exactly. Can't even explain how Mercury stays where it is.
What do you mean it doesn't predict it exactly?
So,
it predicts
you're placing more emphasis on one model than the other. They're both models. I don't try and reify it into reality. It's just a very accurate.
Listen, guys,
whereas the heliocentric side isn't.
That's a misuse of the term reify.
No, no, it's not. It was a correct use of the term reify. I don't reify either the Antikytherian mechanism or any visualization of that into reality. You guys do. You think this heliocentric model is reality.
Do you know what he meant?
It's a correct use of reification. It wasn't an incorrect one, was it?
It was correct. It made absolute sense.
Do you know what he meant, Bob, or you want to argue now about this word reify?
Yeah, I want to make a point. If I sit on my porch for 20 years and every morning I watch the old man across the street come out of his house at 9 a.m. exactly every morning and check his mail, and then one morning I turn to my wife and say, hey, that old man's going to come outside and check his mail at 9 a.m., and he does it, that is not a prediction. That is me identifying a pattern. That's it. That is not an accurate description of what a prediction is. All I did was identify the pattern that the man takes every single morning, and then I said, hey, that pattern's going to hold up. That's it.
Well said, Bob. Well said. Cannot be said better.
It's like looking at a clock on the wall.
You've obviously predicted the old man's orbit.
Yeah. That's what I did.
Do it with the sun.
No,
it doesn't matter what you do it with. Whether you're talking about the moon or the stars or the planets or the sun, it doesn't matter. It's not a prediction. It's you identifying a pattern and the pattern holds. That's it.
Talk to him.
No.
If I say tomorrow the sun's going to rise in the east and set in the west, I'm not making a prediction. I'm just identifying the pattern of every single day.
Bob, you're lagging.
Go ahead.
You're roboting, Bob.
Yeah, we can't hear nothing you're saying, Bob. If you could drop
anyway.
All right, well, no reason for me to say anything.
Good.
Man.
There, I hear you good now.
No, we still can't hear you.
well, I'm glad someone defined predictions and say these are
Forget
not
about
predictions.
Bob. Bob's a fool.
So that was what the ancients did. They make records of what's going on, and they make predictions upon these records. The difference is right now with the heliocentric model, we calculate and we predict without looking back to the history.
All right. Don't look up anything. Tell me when the next eclipse is going to be.
Wait, did you hear what he just said?
Absolutely not true.
We calculate and predict without looking back at history. So you've created a model that captures the pattern, and now you take that model and you say, well, our model captures the pattern. We don't have to look at what happened before. We can predict the future.
No, that's absolutely not true. That's how Kepler's law was based on decades worth of observations to find.
Forget Bob said. It doesn't create curvature under your feet by looking at lights in the sky.
We can't forget they think they know how the sky works, so.
Yeah, but it doesn't create curved water under your feet.
Don't worry about it, man. Hey, Bob was Bob, you're breaking up again, man. I think Bob is BWB, y'all. He's BWB, man. He's born with a fucking blemish.
Which
you said born with a what?
What is that supposed to
He's born
mean?
with a blemish.
And once
Born with blemish.
we knew the mechanism.
Is that another way of calling him retarded?
Yeah, that's our new inside thing. Thanks to, what you call it?
Bob, you're
That's our
ruining
new
the show.
inside thing, man. That's our new inside thing. If somebody's blurting shit out, they're BWB.
He's got an adaptation, that's for sure.
Bob, you're roboting. We can't hear you. You're ruining the show. Just stop.
Yeah, I thought it was flat Earth for an hour anyway, but I'll listen to Bob. But all he's doing
Everyone
is
was
roboting,
so
man.
fucking quiet. You know, I said Bob started talking. I'm like, well, I'll just let him talk. But
If it was coming in clear, I wouldn't mind. But I mean, it's
I was gonna make a point, though, man.
gibberish, not like unlike usual. But
well, I
That
thought
one
he
day-
got us away from
Yeah, go
the
ahead.
point, though. He got us arguing about the meaning of the term prediction and reify. And I thought Adam's original point was pretty good.
yeah, that's why I asked him. Do you want to argue about the word reify or address what Adam said? Bob, you're still roboting.
Yeah, drop and join, Bob. Drop and join, bro, real
On
quick.
my screen, it
We
looks
can't hear
like Bob's voice is coming
I'm
through
not
Crow's.
roboting, I'm not talking.
Oh,
Oh, we heard you that time.
maybe not.
Yeah, I'm not roboting at all. I'm just not
Well,
saying
now
it.
you're not.
It was somebody else then. If
Was
you
it me
weren't
roboting?
talking.
No.
Has anybody been to Sun Calc and check the sun? How you got a little a bar, and you could dial up that you could put the sun's position for any time of day. Okay, so for the 12 or so approximate hours of daylight, it starts at like where I'm at. It starts at about 6:30 a.m. and then you can so if it's past 6:30, you can go back to 6:30, and then if you want to see like right at sunset, you move the little bar and it moves the sun. Okay, and in the summertime, it makes a circle. Okay, because it'll also project the 12 hours of darkness, but it just shows a shadowed sun. So it's where the model would predict the sun to be. And it's just a circle. And in the summertime, it's a tighter circle. In the wintertime, it's a bigger circle. It just basically does the same thing. And the shade part of the shade part of the sun is just a little opposite of the lit part of the sun. In other words, the nighttime, it's just going back around. It's just a circle, man. You can playing around with it. And I was thinking, how could they possibly know? How could they distinguish circling sun perspective wise from the heliocentric model? There's no way.
I don't know.
If you do the angles, bro, just the simple triangle calculations, if you're facing the sun being thousands of miles away at sunrise, like 6,000-7,000 miles, some extreme movements, you're talking like 1,000-mile movements right to left, they would be, you wouldn't even be able to see them hardly, just barely. About how we see, man. Whoever created this place was a genius, man. It was like a super genius, like almost like they were like set out to give you 3 or 4 or more different options using math. It's weird, man.
And that's such an understatement. This place is beyond incredible.
Well, just to think about how intelligent a species could get. Imagine humans, if we keep learning at the pace we have, in 100,000 years. Imagine what we would be in 100,000 years if we kept learning. And
it wouldn't work. It could, like, if human beings were ultimately good and only good, basically if nobody lied, that would possibly work, but it won't work because people lie. And so it's not a matter of just obtaining true information. There's the work of basically sifting through all of the incorrect information, and that's not going to stop being created at least like at the same rate it has been, if not getting picked up and created even more misinformation, disinformation, just incorrect things. Now think about where we would be literally right now, if we could rely on the internet to be a source of everything humans actually knew to be true and nobody lied. We wouldn't have to spend years looking into history, looking into all these things that we spend time trying to dig through and find out if they're true. We wouldn't have to spend time with any of that. We would just, if we need to know something, check the internet. There it is. It's true because nobody lies, and move on. We could reach the point that you're talking about. It wouldn't take 100,000 years. We could have such a vast knowledge right now if people didn't lie. But because they
think about this, I agree with you, Bob. Let me add to that. Okay, what as of right now, they take all the machine heads and they put them in like astronomy and these astrophysics courses, or they have them looking up into the heavens, doing math and all this shit, trying to figure out bullshit, or else they have them chasing mathematical nuclear fusion. They've had them doing that for like 100 years, and it's never reachable. Meanwhile, the people, the electrical engineers, like the next level down from the machine head, math heads, are actually demonstrating the shit in the lab. They're demonstrating types of fusion and everything, and they don't have the help from all the top geniuses and smart guys because they have them looking up in the la la land. And yeah, if they would let out every technology, like Bob's saying, it wouldn't take nowhere near that. We'd already be there probably. Yeah, I don't know, man. I'm gonna have to agree with that. If everything was based on honesty, but I don't even know if that's possible.
My
nowadays.
point was, though, to say 100,000 years. All I was saying was, imagine what we'll be capable of doing if we continue to evolve our technology the way that we have.
I had 2 points I wanted to bring up.
I would say this: considering how far we've come and the awful, horrible things human beings have managed to do to each other over the last several thousand years, I think right now my current attitude is I really hope we don't make it to 100,000 years, because think of the awful things we will have devised by then.
No
yeah,
shit.
Things probably just keep going back and forth, man. I wanted to point this out, man. I was sitting here thinking about this, and we're sitting here watching this guy in the lab. I was going to bring up 2 points and see if anybody wanted to run with them, but I'll bring up one. So the guy has the flask or the container of bromine, okay, and on one side, and then on the other side of the tank, it's one big tank, but there's a valve in the middle. He's got a vacuum on the other side. I think we've seen this on Nathan Oakley. Shout out to Nathan Oakley. Where the professor he starts preaching. He says that if you have pressure on one side and you have a vacuum on the other side, when you open the valve, it pretty much instantaneously equalizes. Okay, and you don't get any energy. There's no change in energy, none at all. Right? There's only a change in entropy, basically, and no energy. So that had me thinking of like rockets. And like rockets in the vacuum, okay? So basically they're doing the same thing. They're letting out energy. I mean, doesn't matter how big the vacuum is. If they're claiming it's a vacuum, then when they're releasing their combusted fuel out of their chamber, okay, then they're saying that there is a change in energy. They're saying they're claiming thrust out of this when everything we see shows that there's no change in energy. There's no temperature change. There's no, resistance. Yet they claim that rockets are thrust and perfect up there. Now, I'm not going to make the claim that like there's no rockets up there, period, at any height or whatever above the airplanes and shit, because I've seen them before. They don't look that high, but they look a little bit higher than the airplanes. I'll give them that. They seem to be hitting some type of liquid type of layer where shit starts rippling a whole hell of a lot more than we see on the ground. And also, like if they are working up there, it's because it's not a vacuum. Okay. It's the whole point that I would rather stress is the fact that it's not a vacuum up there. It's just colder. It's colder up there. It's not there's still air up there. I've been arguing this till I'm blue in the face. I can show a gradient inside containment. I did it on a video. It wasn't a lot, but it was a gradient. Okay. And it was within about 60, 70 foot of PVC pipe. And just by heating up one side, cooling down the other, I was able to inflate a balloon. They don't want to acknowledge it. Every time I talk about it, they don't want to acknowledge that the lack of change of energy. They want to just go on with their paradigm. They want their vacuum and their rockets to work perfect and everything. Any thoughts on that? Anybody?
Well, I have a question of that thing you brought. Oh, go ahead.
No, go ahead, Jeremy. That's cool.
I was gonna say the energy thing when you say heat is a force or whatever, and they say no, it's not. How do they explain their gas molecules accelerating and decelerating with heat? You need a force
They,
for
they change it
acceleration.
up. They change it up to where they're always moving, but not moving. You know how they have to do. They have to say that the molecules are moving, but not moving. They're moving 500 meters a second at whatever temperature, and but not going anywhere. No wind or nothing. But it's moving though, right?
I think
Yeah,
that's
I'm
a
just
good
saying-
point, Jeremy. I mean, if you're just adding heat to something and it moves
And
it,
it's accelerating. It's accelerate. You need a force for acceleration, right? That's what they always say. F equals ma.
Yeah, that it basically acceleration is defined by a force.
Yeah. So I don't know how you say heat's not a force when the heat moves, accelerates the gas molecules. I don't know. It's weird.
Yeah, I had asked Rumpus, man. So he defined the acceleration as a force. You know, I mean, he defined the force as acceleration. Okay, and then he said, so to move things in motion, you know, require a force. And I said, well, can you move things with heat? And he says, yeah. I said, well, then you're heat is a force, right? But
no, heat is energy. Kinetic energy, not a force.
Engine.
Everything is based on potential energy. Basically, everything is based on equilibrium and disequilibrium. Basically, every disequilibrium is a force, and nature is basically. People say it's always disorder, but it's always chasing order. In my opinion,
I really like that definition, Brian. I gotta pause for a minute, and the simplicity of that line of thinking is pretty interesting.
Think about it. It's freezing cold up there, right? But there's still air pressure. This guy was trying to get me on the gradient. He says that there's a SR-71 working at 90,000 feet, and I said, so there's still air up there, then, right? It's a jet engine, so it's compressing air and jetting it out. It's a ramjet, but still. So there's still air up there enough to compress and make an SR-71 fly. Okay. And I mean, and he still would not acknowledge the fact that there's air up there. So here it is. So we know that if air expands, it's created and cycled here at the ground. Okay, so it's a dynamic system. It's constantly created here at the ground. Okay, now we know when air expands, it cools down. So if it's going up, however high it makes it, and it equalizes out by cooling down and shit, and reaching containment. Okay, then that's the only thing that makes sense. If it was a vacuum, it wouldn't be cold. You'd be getting closer to the sun's radiation. It would be hot. And one more thing, that I just made a video. The guy made a good point. They claim the core of the Earth is like 9,000 or 10,000 degrees Fahrenheit. Okay, and where's the heat going? Okay, when asked McToon, he said it's like the handle of an iron. The handle of an iron has to, you can hold an iron all day, but the heat is still leaving the iron, dissipating out into the air. Okay, they say energy cannot be created or destroyed. Therefore, it's got to transfer somewhere, or it's got to be being equalized. Now, if it's got to escape from the ground somewhere, because it's a dynamic, it's a perpetual magnetic freaking oven, basically. It's not just like a one-time coal at the middle, right? It's constantly, perpetually, creating that temperature of near 10,000 degrees.
Yeah, what's fueling it? Yeah, where's the heat going?
Yeah, where's the heat going? It's got to transfer according to their physics. It's got to transfer, and there's no handle on Earth for, you know what I'm saying? And so here it is. So we're supposed to be getting hotter as we go down toward the core, but you go down to the bottom of the ocean and it's way colder, okay, than the top. So, and then you're supposed to, the sun is supposed to be even hotter, and then you start heading toward the sun and you get colder. So getting toward the 10,000 degree core, the closer you get that we know of, you're getting colder, okay? Closer toward the 93 million mile sun, whatever. As far as we know, the closest we can demonstrate, closer you get, the colder you get. Their shit's all upside down and backwards. I think we need to bring it back to simplicity and common sense.
Can I ask a question, Brian?
Go for it.
I'm
Ask the
all ears.
question.
Yeah, if I have a candle in a room, will the room be as hot as the candle eventually?
If there was nothing else, you know, if there was no other nothing else at play, I guess, if it was perpetual. But no, not at all. I think that the heat dissipates into the air. What doesn't heat dissipate faster through solids? Doesn't it transfer faster through solids than air or gases?
Yeah,
I mean,
that's
it transfers
convection
faster.
versus conduction. Yeah.
Yeah. But like the center of the Earth is smaller than the surface of the Earth, so there's more space for the heat to dissipate into. Just like the candle inside the room, it can't heat the whole room because the whole room is so much bigger. And there's not enough energy.
Can I heat up rock around a fire pit?
Yeah, you can.
Who conceded the
So
center
not
of the
enough
Earth?
energy. Wait, not enough energy, but it's making the Earth.
All right, so I have a
magnetic.
basic question. Okay, so everybody understands everything that's been said. What Aaron just said, we understand. What the guy who just challenged Brian said, we understand. It makes sense. So I have.
No, it doesn't.
Okay, hold on.
No, it
Okay,
doesn't.
all right. I see. You can bring that point up if you want. Okay, I'm just conceding for a point. Tell me at which point, as we get closer to the core, it'll start to heat up. Because what Brian said was, the closer we get to the source, it cools down. So at what point, hold on, at what point from the surface of the Earth, going toward the core, are you going to start having the outside rocks getting heated up?
I mean, it's not too far down in the solid ground because we have like heating wells over here in
Okay,
Finland
I'm sorry to be a dick. How far is not far down?
Diamond mines.
Yeah, mines and just like you can, I guess 50 meters, 60 meters of pipe, like vertically, you can get heat from the ground, so you can heat your house in the winter over here in Finland.
Okay,
Don't quote me on
so
the number,
all right. So what I understand you to say basically, in general, is 50 meters down, it starts to warm up. So then, by inference, the farther I go down, the hotter it's going to get. Is that what you're saying?
No, respectfully, Travis, that heat is caused by the sun from the hollow Earth. Yeah. So eventually, when you go even lower, it starts to cool down after that.
You're tweaking my melon.
They claim
Is
it's
that
from
where
the.
La La Land is?
Well, this is
Yeah,
all
but-
La La Land. What kind of shit?
No, that's not their claim, dude.
Thank you. Finally, somebody said it. Thank you, Adam. This is all bullshit. You're assuming. How
Right,
do you
right,
know
right.
what's at the center of the Earth? Let's start with that. Reality.
Yeah, exactly. That's what we're waiting on. We're waiting on somebody honest to say, well, we're not sure, but that's what somebody be honest from the globe side, Bring a little honesty and say,
Brian,
we
the way
really
you're
don't know.
talking, you're giving it to them on a silver platter. You're telling them there's a core and it's this and it's that. No, there's absolutely no proof. The only proof we have is 7.8 miles down in Russia.
I like seeing them
Bora
Huey, I
Bora.
like seeing them blemish, bro. I can't help it. I like seeing them blemish.
Yeah, okay, but as long as you say that it's a fantasy because that's what it is.
Okay, so SE. So look, let's take their 50 meters because 50 meters is nothing to 7 miles, bro. Nothing. Yep. So surely, from 51 meters down to 4,000, it's going to get hotter.
There. Yeah. And they have no clue, Travis. Absolutely no clue.
Essie, you are the priest of the borehole. How hot was it when they drilled the hole? How hot was it at the 8 kilometers?
If I remember correctly, and I'm going by memory, don't execute me. They predicted 120 C, and there was 100 C hotter. But this is going by memory now. I did this like a year ago.
Sure. So it gets hotter the deeper you get.
No, it gets from zero, from the Earth top, to 7.8 miles It's around 230 C, if my memory is correct. But the point here is they got it wrong.
Yeah,
Sure,
but
did that
the
register?
actuality is that it
Did
was
that
200
register?
degrees Celsius. Yeah, they predicted it wrong, but it gets hotter the deeper you go. You just said
It gets no, that's not a good statement. It gets hotter from the surface of the Kola borehole in Russia to 7.8 miles down. After that, we don't know what happens. That is the correct statement.
Why would it quit getting hotter, Essie? Why would it stop doing that?
I don't know, and you don't know either.
No, it only makes
Yeah,
sense.
where is the heat source?
Okay, so
Yeah.
so listen, all we need to do is go out to some remote place in Nebraska and drill another 8-mile hole and see what happens.
Well,
right? Otherwise,
no, they're skirting away from the issue. They're claiming because we dug 7.8 miles down, they know that at the center of the supposed sphere, there's a molten iron core. Don't let
Essie,
get
who
away
said
from that.
Which one of us said that? Who was it?
Yeah,
That's the model. That's the model.
Quote me.
You do
saying
not know your model?
I do know my model, but I didn't
So
say
there is not a molten iron core in the center of your model, sir?
there is in the model. Yeah.
There you
Yeah,
go.
and
You didn't find it by drilling a hole.
right.
let me tell you more about their model. It's not
on.
the sun.
You didn't find it, period, Bob.
Listen, this guy just whined. This guy just whined and bitched at SE for saying what he said, and then when SE pushed him against the wall, he just conceded to what SE said.
No,
he didn't.
I didn't say. I never said that there is a molten iron core. We were talking about the temperature of the Earth.
And no. Then
You can.
Then
I
SE
told you-
said. Then SE asked you, "Is there a molten iron core?" And you said, "What, sir?"
Yep.
There you go. Thank you.
No, that's not what he asked. He asked, "Is there a molten iron core in your model?" And I was talking about temperature with depth. I didn't quote the model. I didn't say anything about the model. I said that you can dig a 50 or 60 meter hole to get heat from the ground.
Okay,
That's
stop.
what he
Okay,
said.
hold on. Just real quick.
That's what I
Hold on,
said.
just real quick. Okay. Do you believe that the Earth has a molten iron core?
I do believe that.
Thank you, sir.
Okay, and we weren't talking about the molten iron core. We were talking about heat in the ground.
Now let me say this. Crow
Regardless of
used
shape, though, I mean, regardless of shape, if I drill a hole, let's just say it warms up, it does not tell me anything about shape, right?
No.
Yeah, but I was just saying that you can keep a hole and you can get heat from the ground. That was my point.
That's
You
about
could
all
in
we
certain
know.
spots, maybe.
That's about it right there. And actually, I wanted to address something Howard said. He said, it only makes sense that the deeper you go, the hotter it gets. Why? I don't understand that statement, Howard. Why would that be the case? I mean, you're making an assumption. Yes, if there's a molten iron core in your model, that makes sense. The deeper you get, the hotter it
Exactly,
will get.
Brandon. Exactly. You got it.
Now leave out whatever is at the middle. If you're getting increasing temperature with depth, it only makes sense that it would continue to increase with increased depth.
No, it doesn't make sense. No,
it doesn't
does not.
always do that, Howard. Yeah.
Why does it make sense? No, it does not make sense. It's purely an assumption on your part.
It makes perfect sense.
There's also, as we well know, there's water that comes out of the earth in deep springs and wells and things, and water can come out of the earth very hot, incredibly high temperature, or it can come out incredibly cold.
Yeah, it
And
varies.
as you get closer to the sun, apparently it's hotter as you get further away from the sun. So logically, that makes no sense. So you can't just say, "Oh well, the deeper you go, it would make logical sense. It would get hotter." Like in your own model and scientific paradigm, that is not reality according to the narrative. So you can't go there.
Right, and Crow used a candle in a room to try and describe it. Now, I'm going to use more of something insulated. Okay, now if you take a hot coal and you put it in like a koozie or something, okay, then you're not gonna feel it. It's gonna dissipate. And but if it's perpetual, and you're talking something, you're not talking 120 Celsius. You're talking, 9,000-10,000 degrees, and it's perpetual and massive, and there's nowhere for the heat to go. The heat has to. I mean, by their physics, energy cannot be created or destroyed. So they say that the heat is what spreads, and that's how air conditioning and refrigeration and heat pumps and shit is based on that fact. Okay. So
and Brian, they had to, when they dug the Bolar core hole there in Russia, I think they had to drill through snow first that wasn't melting.
But the thing is, would it make sense to say that as I go deeper, I'm finding higher temperature? Would it make sense to think, I bet if I go deeper,
you've never done it, Howard.
No,
not at all. Hold on, real quick. Not at all. Has anyone ever been swimming in a lake and gone through different temperature layers in the water?
Oh yeah.
Absolutely. I've also done scuba diving. Quite a bit of scuba diving. And when you scuba dive, the layers can change dramatically. Sometimes it's very warm and lower layers, colder. It changes. Yeah.
I peed in the lake.
Dude, we have hot spring here in Florida. We have hot springs and cold springs, not even that far from each other, man.
I am never going swimming with you, Jeremy.
That's funny, but look, no, man, I'm gonna forget.
Jeremy was
the point is the core of the Earth is supposed to be a tenth of the size, or even a 20th of the size. We're not talking about just some small little chunk of heat down there. We're talking about something that is self-perpetual. It's not coming from the sun. It's not claimed to be. It's claimed to be from the beginning of the planet's formation, and it's radioactive, basically, from radioactive decay and shit down there, is what they claim. They don't claim it's coming from the sun. That would be interesting if there was a point where the heat came to a standoff, the heat from the sun and the heat from the core, but that ain't the case. The core is supposed to be a good size of the Earth, so picture a koozie. If you had a piece of coal in there, it might dissipate, but if it was perpetual and it was constantly regenerating itself, and it was, a tenth of the size of the koozie, insulation could slow it down, but it could not stop it because the heat has to transfer, or it has to dissipate into something. And we're not really seeing that.
How is it, Ryan? It's a bit like rotation. You're making excuses why you're not seeing an effect. First prove the heat source, that you're then going to make excuses for why you're not experiencing the effects of this heat source.
Exactly.
Yeah.
Well said, brother.
Well, how is this not a perpetual motion machine that they're describing here, or a perpetual energy source?
Which came first, nickel and iron in space or heat?
Brandon, I believe it violates the first law. This core of theirs.
What's the equation?
And the third law.
All right. What's the equation for how gravity stops incrementally from pressurizing a mass at the center to be as hot as 10,000 degrees, whatever.
Allegedly, there's no gravity at the core, Travis, too.
But listen, how did it start then? Because mass attracts mass. So mass had to attract mass.
Core, though.
Listen, then how do you get any core at all, bro?
Exactly.
Right? So, okay, but see, the whole thing is, right? So let's say we got two little atoms that attract each other. Like, hey, what's up, bro? Let's get together. And they start to get together. And then they start to produce some heat, right? And then everybody's like, hey, it's really cold out here on the outside. Let's get closer to those bros over there. So they start going. So then all of a sudden, why does it stop, right? What's the equation for that, bro? You got an equation for that?
They try and use bendy space-time now because the attracting mass didn't work, namely for Mercury. Okay, it's so close. Okay, everything's effed up with Mercury, in my opinion. But then, so they say that space and time as one bends, which is a load of shit. So I guess the bigger something is, the bigger the lines bend. And I guess if they reach a certain size, then bend in on each other to infinity. It just flies in the face of common sense, man. Black holes, shit like that.
Back to what Brandon was saying about perpetual heat, though, and perpetual magnetism, spinning, whatever these eddy currents are. That, I mean, There needs to be an explanation. Come on, guys.
There is an explanation.
What is it, Howard?
I don't know.
Yeah, what is it? What is it, right lane?
It makes
wait.
sense. It makes
Guys,
sense.
guys,
Wait a minute.
Can we
haven't
please
gotten.
have? Can we please have Left Lane finish his question? I want to hear. I think I know what his question was going to be, but I would like him to say it. He'd started saying, "Doesn't it make sense?" Something. I would like him to finish his question, please.
Oh, we talked about it, about the increased temperature with depth.
So doesn't it make sense to what?
I would expect temperature to increase as I went deeper.
Yeah, we talked
Isn't
about
the
that. Bob.
temperature increasing something? Is that something that they've measured?
Right, but
Yeah,
that's when I'm sorry, but that's when I jumped in and said, hasn't anyone been in the water and gone down through different layers of temperature?
Yeah, we're
Yeah,
repeating
but that's not analogous.
Or
Travis,
let's take it to the
okay,
other-
how do you wait. Why isn't it analogous, bro?
Because the ground is solid, Travis, not water flowing. Yeah.
So Howard, let me take it to the other extreme real quick. So as I get closer to the sun, which you would say is a heat source,
Aaron, before you go,
as I go up, or no?
Aaron,
Like you're
before you
saying get
destroy the
hotter when you go down?
conversation, I want to know if I'm understanding Left Lane's. Are you saying that because we've detected heat further down, that are you asking? Doesn't it make sense for us to assume there's a giant heat source down there? Is that what you're asking?
No, I never said anything to do about assuming a heat source. I just simply said if I'm experiencing an increase in temperature with depth, that I would assume that if I went deeper, I would experience a higher temperature.
Okay, so if you're experiencing heat that gets progressively higher as you go lower, wouldn't you assume that would continue to happen?
Yeah.
Is that what you're asking? Oh, okay. Okay. I misunderstood what you were saying then, and that's fine.
If that's your logic though, Left Lane, wouldn't you assume that it just keeps getting colder as you go up?
What do you mean?
Well, it gets colder as we go up, right?
Well, yeah, generally speaking, that's true.
I know. This is the part where you play games and you skate and do all kinds of global
Right.
I'm not playing a game at all. I'm not playing any game.
Jeremy, sorry, Howard.
He said that he thinks that that's generally true if you go up
So
higher.
Howard, as I get closer to the visible heat source,
just
we
what it
call the
sounded like,
sun,
maybe.
you're saying it should get hotter and hotter, right?
Maybe not.
Just like if I go down to the center of molten iron core, it should get hotter and hotter. What happens when I go up in a hot air balloon or an airplane or climb a mountain? What happens to temperature?
It's well known that temperatures tend to decrease with altitude.
But I'm closer to a heat source. Why?
But we're getting away from the very simple idea that if I'm drilling a hole, I'm experiencing greater temperatures with depth. I would expect that if I drill deep.
JQ, Gemma with the G would like to talk about the analema, but her name is banned, which is a dilemma. That's pretty good. Pretty good rhyme there. Thanks, JQ. Good servant, 99 cents. What's up, man? James Mays, $20. What's up, Brandon? Hello to the panel. Thank you, James. I will say hello to the panel for you. Appreciate it, man.
Well, if I go from the surface into a cave, at least down 200 or 300 feet, it's a lot cooler, isn't it? And as Travis describes, if I'm going to build that into a presupposition that we've got basically a red hot radiator at the center of all this, then you're missing what Travis said.
That's where the logic comes
with
in.
water. Why just because over a very small percentage, what is 8 miles over 3,500 miles, why over that assessment range do you feel you're able to draw a conclusion if you continued? What happens if actually at 25 miles, right, that's where unicorns mate and the temperature that unicorns mate at creates such a heat that it means when you get to a certain level, it heats things up. None of these things, even at 25 miles, could you even get close to validating or disproving the nonsense that I just suggested, which is just as good and fits your correlative data just as well.
Now, your nonsense makes no sense. Thank you, sir.
It did just as well.
The fact of the matter is,
But
they
that's
hit
just
a
a weak
sludge.
hand wave.
They hit a sludge.
What's below the unicorn?
Hold on. When they got down there, they hit a sludge that.
Wait. The unicorn. What's below them? What's below the unicorn?
With the hardest drill bits available at the time, they couldn't get through this sludge. I mean, ain't that kind of a contradiction in term? Dense sludge.
To go from experiencing hotter temperatures as you go down and jump from that to wherever the alleged center is must be molten, a molten core, that is illogically. There is no connection there. It could just get warmer as you go down. You don't know if it stops at some point, stops getting warmer. You don't know if there's a point where you just can't go any further and so the heat can't get any stronger. There's nothing to suggest a molten core just because there was some detected temperatures raising as they went down a very small bit. That's a
Let me make a point here, an important point, if I may.
Simmons, did you get both garbages in the bathrooms back there? Did you get both those garbages
Jeremy,
in the
you're
bathrooms
hot.
back there?
You're hot, Jeremy. Yeah, you're hot. Let
My bad. All right.
Let SC make his point, and then I've got a conclusion to make about my thoughts on it. Go ahead, SC.
Yeah,
Okay,
thanks.
great.
It's important. If there's any misconception that they stopped drilling because of heat, that's not the case. The reason they gave, besides some political stuff and monetary stuff, the mechanical reason they gave was that the substance they found at that depth was like, they described it like, first I read molasses, but then they updated it. It was like a plastic kind of, like they would dig into it and nothing would happen.
Yeah, they hit a border. In my opinion, they hit a border. But my
They
conclusion.
couldn't go any further. Yeah. Why?
Yeah,
My
they couldn't go any
conclusion is-
further. Yeah,
My
That's the
conclusion to all this is,
constituents of a unicorn's nest.
say jet
exactly.
streams.
Right
Let's go with
under
what
there
we
was
can
the
see and measure.
unicorn.
Let's go with what we can see and measure. Okay, so I say that the world works off of constantly trying to equalize. Okay, so what I claim is that the air that's created at the ground, basically, and cycled at the ground, is expanding up to elevations, however high, and it's expanding, so it's cooling down, and it's also okay. So you have to have a point. So my example for that was like the albatross flies. Come to find out, 2 years at a time, sometimes out on ocean currents, and without even flapping their wings. So there's obviously wind, and it's circulating up. The clouds are proof of that. The jet streams, you're talking about some serious power. You're talking about a whole lot of power, and it's coming from nature just trying to equalize, just the hot go into the cold, and them meeting. There's got to be, in my opinion, though, there's got to be some kind of containment to force that. Can anybody think of a way around that? And could anybody? My last question would be, okay, if there's no change in energy from the gas expanding into a vacuum, why would it be cold up there? I mean, if the gas is expanding into a vacuum, there's no change in energy. Okay, it wouldn't get colder. It would there'd be a change in energy.
There's definitely no vacuum up there. That we can be certain.
Prove it.
Okay, it's gonna be conclusion. And
That opens up my mind. That opens up my mind to the potential of rocket.
End with the question.
What?
When you make a conclusion, you don't ask a question at the end of it.
Well, my conclusion is that it's perpetual. Okay, the hot air coming from the ground. Okay, rising up, filling the space, expanding up, cooling it down up there. Okay, and my conclusion was there's got to be a limit up there, or else it wouldn't be cold. Why would it be colder up there?
Why is it cooling down? You forgot your experiment from before. Nothing cools down, just expands.
Air cools down, but if it's
James Mace again, $20. Thanks, James. Really appreciate it, man. Very generous of you. Says trying thinking and ranty for debate. Hello. Oh,
you have to.
I'll read it on there. You said hello to SE, and I'll read both of yours on there or on the Discord. But thank you. Yeah, I'd be happy to have them in for a debate. Try thinking and Ranty want to come in and have a debate. It's fine. It's always open for anybody who wants to debate. Almost anyone. Gemma without the G. Remove the G from my name. My name is banned. Help. Thank you very much for the $1.99 super chat, Emma. Appreciate it.
You said.
What do you? Okay. Keep it on point. What do you say causes the jet streams, Chikey?
Right. You said in your experiment, when you open something to the vacuum, nothing changes. No temperature, no energy, nothing.
Entropy.
Just entropy. So why the hell does the air cool down up there? Just
because it's expanding. Because it's containing.
Brian,
it's contained,
Chikey. Expanding.
It is.
It never
it's
cooled down.
Contained. Chikey, when you expand air, okay, it's created at the ground, okay.
Any gas, yeah, any gas.
And if it's cycling through jet streams up there, okay, it's constantly cycling, okay. It's constantly circulating around the plane, okay.
Evaporating, expanding.
So if it's expanding up into the jet streams, then so wouldn't you expect colder temperatures unless it was a vacuum, and then the air wouldn't cool down? What do you say is making the air cool down up there?
Jesus, Brian, the air is created at the ground level, expanding up, and then sucked back into the ground.
Thanks, Nathan. Dynamic system.
Yeah.
It's reality though.
Back into the ground.
Aaron, it's reality.
What does make it go back into the ground?
Say again?
Several things, man. Several things.
Yeah. Now,
go back into the
claim
ground?
that it's going to be an open system, right? So, but what he just described with Brian right there was basically a closed system. You know, when I say system, systems, environments, conditions move up due to temperature and condensation, evaporation, humidity, blah, 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 wind and temperature, and then come back down, right?
How?
Just like ocean currents, right?
Yeah, these cycles are not in question, are they? Are you questioning these gas cycles?
The cycles don't create gases.
Well, I do question.
They don't create what?
Exactly.
Indeed.
The cycles don't create gases, is what he said.
Well,
and I would also say that
you try to take a container and
the cycles never lose gas either.
At the bottom and see what happens.
Otherwise, we'd be stagnant.
Are you saying that it just recycles the same gas over and over, or what are you
recycling?
saying?
How the gas is recycled?
Yeah. Is oxygen recycled? How does the oxygen come from the sun?
Okay. Don't the trees produce oxygen?
Wait. Gases aren't created, are they?
Photosynthesis, or whatever.
Isn't it just a change, like one state of
chemical
one state to
transformation
another
in
state, like
nature?
steam?
I hear five people
Hold on,
talking.
what, Bob?
Gases aren't created. From my understanding, it would be that gases aren't created. That it is simply one thing changing to a different state. So, like whenever you boil water, it then changes into steam. It changes its state, and then it is able to go up rather than being kept down. Right? That's how that works. So the idea that couldn't work with other things in our larger ecosystem, why not? Why could it not work with other things? It basically is allowed to go up because it separates out enough. Okay, like Brian was saying. Okay, and then eventually enough of it comes together long enough that it will come back down, just like rain does. It gets evaporated up because it gets separated
Would you
enough,
like to
and
know
then
how it
eventually
actually
it
happens?
comes
And
together
nothing is
enough
lost
and falls
in
down
that
again.
process. There is no loss in that process at all. Otherwise,
Go ahead, Phil.
No, I
How
didn't.
does it-
I didn't
how
say
does
there
it
was a
really
loss.
happen,
No,
Phil?
Bob,
If
I'm
you get
agreeing
them to
with
be
you.
quiet, I'll explain it.
Oh wow.
Okay.
Here we go.
oxygen is created by breaking the water molecule during the process of photosynthesis. That's how it
Created.
happens.
It comes out of nothingness.
It doesn't come from nothing.
Well, then it's not created. It's changed.
Yes, it starts
That's
off
provenly
as,
false, man. This is the 2020 to 2020.
To create something means you made it from nothing else.
Easily
That's what
proven
creation is. So you could
No,
say
it
that
isn't.
it changes
It's a
from one
chemical
state
reaction.
to another state because of that thing. The cause causes it to change from one state to another state, from something else into the oxygen. That's fine, but it doesn't create the oxygen. Then it just changes the
It
state.
breaks the water molecule.
So it changes the state.
process of photosynthesis breaks the water molecule that creates the actual
Define
oxygen.
breaks.
The rest of it is combined with carbon and other minerals to create the wood for the plant. That's how the plant grows.
Define breaks. What does it do when it breaks it?
The bonds break.
They come apart.
It's chemical
Yes,
reaction.
the oxygen
Okay.
becomes
Okay. So if they come apart, that would indicate that the pieces are still there, just separated, right?
well, they bond with the other materials that are there, like the carbon. The hydrogen bonds with the carbon.
Is anything
The
permanently
oxygen
destroyed
bonds-
to where it cannot be retrieved in any way, shape,
Why
or
don't you
form? Is
just
anything?
why don't you just be quiet and listen, and you'll learn something. Today
Well,
will
look,
be a
we can
different day for
demonstrate.
you.
Hold on. We can
You're
demonstrate
talking nonsense.
upon
You're saying
closer
that something is
examination.
Wait a
made
minute.
from nothing,
I don't
and that doesn't
understand
happen.
what the I'm not picking up on what the disagreement is about. Okay, so the plant takes water, you say, and breaks it apart and creates oxygen and whatever else.
Okay, and the hydrogen that was with the oxygen becomes part of the wood. You know, the part that makes the plant grow.
Okay,
All
so
the
oxygen is
materials
essentially
made of it.
like a waste product of that process. Okay. So
Yes.
Bob, what is
Yeah,
your
so-
what is your issue that you're taking with that? It's actually creating some new matter. I
That's
don't
what we
think
were
that's-
talking about.
No, I'm just.
We were.
I'm
It
explaining
isn't
to you
creating
how-
anything. All it's doing is separating one thing from another. It's changing the state. That's it. Just like I said, and he disagreed that that's not how it works, and that is how it works. That's exactly what he just
No,
described.
changing the
State
state
is
is a
changing.
different thing.
That's not what happens. It doesn't make wood, does it? It makes oxygen and glucose.
Yeah, let me take it a step further, guys. If you try and
Doesn't
feed a
make
plant
wood.
distilled water, okay?
Hold on, Brian.
Making wood.
It's not
I know
changing the
Phil's
state.
probably got a bit of wood
Yes, it
because
is.
he's had the
You're
chance to
changing the
dig
state
it.
of being together to the
Jesus.
state of not being together. It's that simple.
No, that's not what changing the state
Hey,
means.
do you guys know that Brian is a chemist? I think you
State of
should let him
man-
speak.
Adam, yeah, let's
sorry,
That's
Adam,
what changing
my
the state
apologies,
means
sorry.
in chemistry.
Let me ask you something, for Phil. What is the net balance of gas molecules during photosynthesis?
Well,
Dude, they have,
in this
O2 in and O2 out.
we can
in this
easily
case-
prove that photosynthesis is not
Well, I
creating
asked
oxygen.
something, Brian.
Very easy to prove.
Never mind. Stay ignorant. It's okay.
No,
No,
go
I
ahead, Phil.
didn't
We
do
know
it.
your
Brian,
explanation,
shut
man.
up.
But nowadays we're starting to realize that everything is electric. Okay, the water, the plant
Yeah,
is using
used to wait,
electricity.
Brian,
Okay,
used to
if
wait.
you try to feed a
That's
plant
bullshit,
distilled water and grow it in sand, okay, you're going to get nothing. Okay, if you give it distilled water in a pot and you keep going and going, as soon as the minerals are gone and it can't transfer the electricity, I mean, it's not conductive, then the plant's gonna start breaking down. You could grow a plant in a bottle, okay, and show that the bottle is not accumulating oxygen. It's easily proven. Anybody go see Peter and Pete's, they've demonstrated this. Everything's
Yeah,
electric, man.
Peter and Pete are freaking lunatics.
Yeah, now
But
can I
they do
hear
demonstrations though.
Brian,
okay? I'm
can I
not.
hear the answer to my question, please?
What's your question?
What is the net balance of gas molecules during photosynthesis?
Yes.
Yeah, I agree. Everything's always trying to balance.
Brian,
No,
if you know the answer, answer. If don't, let someone who knows answer it.
What's your question, man? What's your question, man?
I need to repeat it the third time, Brian.
Yes, I don't understand. Sorry.
What is
Why
the
don't you
net
direct
balance?
your questions to Adam? Try
What
that.
is Adam can answer it if he wants. What is the net balance of of gas molecules during photosynthesis?
Yes, CO2 in and O2 out. How much? What's the difference?
You didn't hear nothing I said. Okay, we can prove that the fucking plant is
Wait,
not
wait,
emitting
Brian.
oxygen.
Wait, Brian. Wait, Brian. That's not an answer.
Does anybody know what the net balance is?
I attribute it to heat.
I'll take a guess at 0.
I pasted the formula, the photosynthesis formula in the
His
chat.
basis is wrong, dude. It's
How much
not
gas was
creating
created
oxygen,
during
bro.
this process?
You
How
get
much
ox-
gas
you
was
get
created?
O2,
All right.
you get O2 out, and then the rest is converted into sugars.
So
Carbon
how much
dioxide
gas was
plus water.
created? It's a simple question. How much gas was created during this process?
None.
I'll take a guess.
So where are the gas that's created? Where are they
And
created?
statements
You
as
said
an
gas
argument from inherited
created.
from someone else. That'll be my guess.
What do you say, Rakia? Couldn't hear you.
That left lane doesn't know anything about this subject. He's just heard this argument and stating it for a case. That would be my guess.
What are you talking about? What the hell are you talking about?
Look, plants do not breathe carbon dioxide. Okay, we used to think that. Okay, we need to update. We need to update
Yes, they
science.
do.
Okay,
Well,
no, they do not. They do not
Yes,
emit
well,
oxygen.
no.
Okay, let me tell you what's likely going on. Okay,
plants don't.
It's likely,
Don't
huh?
emit oxygen. Holy crap, man!
Well, this is news to me too.
Howard,
Is
Howard,
this
it's real easy to prove,
a recent development, Brian, or is this a
yeah.
theory or
So
what?
many experiments, man. So many experiments of people pumping carbon dioxide in jars with plants and shit, and then testing the gas. Okay, over and over and over for the last few decades. You know, that you could pump carbon dioxide in a jar. Okay, you don't wind up with oxygen. Okay, it was a great theory back in the day. Okay, but now we know everything is electrical.
It's well understood that plants consume CO2 and produce oxygen.
Plants don't eat water. Okay, the water is a source of the electricity. Water is the source of the electricity, but you need the minerals. You know what minerals are? Minerals are salts. I want to say, magnesium, all these
Zinc,
phosphorus, they're salt, man.
Sulfurs.
And stars, they're conductive, right?
Brian.
Brian, you're debunking the guy.
This is the first time I've ever heard this. Who's considering this CO2 thing? Is this something that mainstream science is talking about, or is this coming from somewhere else? Not that it matters. I'm just curious.
Yeah, Peter and Pete probably.
I don't know. You should
Say
be
that
the
plants
expert
can
of
absorb
gas
CO2. They
production.
can absorb CO2.
So
They don't
where
breathe it.
where
They
is
don't
gas
breathe it.
created?
Replace it with
Where
oxygen.
gas is created.
If you want a good explanation, go and watch Richard Feynman's Fire. Little thing, little talk. But you might get a strike, Brendan.
Okay.
Where do you think it's
Yeah,
created?
look, man, everything. Look, like they say that oxygen is created like on the shorelines from all the plankton, which is supposed to be a plant. I mean, which is supposed to be animals, but they act as plants, and they got to keep their freaking theory. So they've got to turn an animal into a plant, and they've got to have it breathing in carbon dioxide and breathing out oxygen. They got to keep it plant-based, okay? But in reality, plankton is an animal, okay? And what do you have in common on the shorelines and in the rainforest? You have heat. Okay? Even if they try to gather some of these plankton and isolate them in a lab, okay, and put CO2, you'd get heat, okay? So in my opinion, it's simple shit. It's more just dynamic. It's more Mother Nature's way of equaling out. So plants don't drink water. Okay, distilled water is going to do nothing for a plant. It needs the minerals to go with it. What do the minerals do to the water? Make it conductive. Okay, they make it conductive for it to, even go through its chemical processes. Sure, they may absorb CO2, but they're not exchanging oxygen for CO2. That's easily demonstrated. Just grow a plant in a jar, pump CO2 in there. You don't wind up with oxygen. It doesn't happen. It was a great theory for the time, but it's inaccurate.
Yeah, go get you some biology courses, and you'll understand how wrong you are about that.
Well, I'm trying to update from our current knowledge. I'm not trying to cling on to shit like the old freaking scientists who won't let go of the past. Okay, we need to move on. Okay, we need to update all these theories in school books and shit, and at least admit that we're not 100% sure how. But everything's electric. That's for certain.
So, Brian, my question was simple. Where are those gases created?
Tyke, for the last time, bro. They're cycled. They're cycled. Cycled. You hear me?
Cycled. It's not created.
They're cycled at the ground. They're cycled at the ground.
You're the one
Where do they
claiming
come from?
they're being
Where do they come
created.
from? Yeah, where do they come from?
The ground. They're cycled at the ground. When shit dies, it decays.
Why?
It okay. And heat. You know, what heat does to water vapor. Heat. It dissolves water. Okay. And then you wind up with supposedly multi-million pounds of clouds just floating in the air.
Where the
How
fuck
do you
else are
describe
these
that?
things going to happen at? It's got to happen at the ground, right?
Where does Chikey and Left Lane think gases come from? I'm curious.
Where else could it come from, Chikey?
They don't come from. They're here.
Most of the gases come from the ocean. That's why the ocean sea level dictates the 14.7 psi on Earth. Because that's where most of the gases are coming from. Laugh. I know it's funny.
Yeah,
Let him,
sea level, ground level.
Jeremy, let him explain where they come from. I'm curious. Chikey.
Where do any
What's
of the
up, bro? Left Lane, what's up?
Yeah, my original question was, why does the air cool down?
Are
was the
you
original
refusing
question?
to answer the question? Are you scared?
Yes, that
Where
was
gases
the
come
original.
from?
And
We answered you.
Brian
The
started
boys
to go
answered you.
about
Now it's your
gas
turn.
cycles and how they created at the ground level.
They took
That was the beginning of my conclusion.
exhale, plankton. Now, what's your opinion there, Left Lane and Chikey? Where do gases come from?
Yeah, Chikey, I said that if
They don't come from
gas goes up
anywhere.
into the
You
expanse,
have no answer.
up into the air,
All right,
cools
hold
down.
on, bro. Let's laugh a bit. Chikey, Left Lane. You have no answer?
I told you they're here. They don't come from anywhere. And they don't go anywhere, basically. Not much.
So they're here.
They're here,
Okay, like
yes.
King Kong is here. How about you, Left Lane?
Yes.
Where do gases
Where
come
does
from?
I don't know. Where do all the elements come from?
Another you don't know. Okay. I rest my case.
I thought they exploded from a single point of mass or singularity or something. Isn't that?
Yeah,
the
but
story?
wait. First they gathered. Brandon, first they
Big
gathered.
Bang or something like that? Yeah.
First, the
Bullshit.
gases in a vacuum gathered, building in gravity. Okay, even their story of creation is a contradiction. They got gases forming, clumping together to create stars that then create matter and other gases and shit like that. It's a
Yeah, that's their La La
contradiction.
Land story. But do you see, Brian, when I press them, they're trying to ridicule you and other people. But when I press them, what do they know about gas? Where do they come from? Did you see the answer that they gave?
They come from.
Yeah, dude. That's why I always fall back on demonstration.
Everything came from the universe.
I always fall back on demonstration, man.
Hold on.
Brian told us about the cycle.
What? Say that again, mailman. I couldn't hear you.
Yes, Essie says that we don't know where gases come from, but Brian didn't tell us where the gases come from. In Brian's example, gas
No, but I told you. I fall back on demonstration. I see their cycles. Okay, I heard my name, guys. Hold on. I fall back on demonstration. I fall back on what we can show and prove, and I say the gas is. I don't know where the creator, what order he created shit. Okay, I just know that it's cycled at the ground. It's cycled at ground level.
All right. We've established that. Oh, Matrix, your mic is shit.
Sorry. So you guys hear me now?
A little better. Yeah. Go ahead.
Sorry, if I talked over you. I can't hear you.
Right? We didn't eat farts. We create.
Oh no, it's no good, Matrix. Sorry.
Yeah, I have a question for Brian.
Yeah.
Yeah, there's only enough room for one bad micro.
Hold on,
these
I'll let you
parts.
ask that question, mailman. let me read these super chats real quick if you don't mind, because I've been sitting on them for a while. Carlos 888, happy birthday to me on this beautiful flat Earth. Happy birthday, Carlos 888.
Whoa! Happy
You want us to
birthday.
sing? You want us to sing? No, I don't think so.
No.
I don't think you want us to sing. James Mays, bring trying thinking and ranty for a debate. And he says, hello, SE and Adam. Shout out James Mays, $20.
Hello, brother.
Hey, Bev, forget that. Bev was fool him.
That would be interesting. I'd watch that. Bev versus Ranty. That'd be interesting.
Oh yeah, I'd pay to watch that.
It'd be freaking hilarious. The first thing I'd ask Ranty is to scale his drawing and give me a vertical scale and a horizontal scale. Like even on blueprints, they're scaled differently because perspective shows them differently. Like he's going to try and say that there's 500 something meters in that little span of mountain 80 miles away or 50 miles away and try to compare it to a sloping bit. I mean, let's compare it side to side. Let's use above that mountain. Like if it was nighttime and there's a star the equal distance above that mountain. So are you trying to say from the top of that mountain to the star is 500 meters? Does everything match different distances away? It's blemish, man. It's born with blemish shit, dude.
James Mays, $20. What's up, Brandon? Hello to the panel. Hello, James. And JQ, $5. Gemma without the G would like to talk about the Analema, but her name is banned, which is a dilemma. Thank you, JQ. Good servant, 99 cents. Shout out, man. And Emma without the G, Gemma without the G, remove the G from my name. My name is banned. Help. All right, I'm good. So what was your question?
Yeah, do you have Emma banned, by the way?
Let me respond.
Emma UK?
Yeah. Yeah, Emma's banned. Yeah. She has been for a while.
I watch Pete and Peter, and I wanted to know, Brian, what is that fizzy stuff that's in carbonated drinks?
Pretty sure we inject carbon dioxide, right? Right? We inject it in there, right?
Yeah.
Coffee.
Well,
Carbonation, right? Dude, you ask stupid questions, bro. You are digging so deep.
Them make the claim that carbon dioxide's not a thing, and then you're.
Who says carbon dioxide's not a thing?
So I hear the claim that plants don't absorb carbon dioxide, and it's shocking to me because.
Who said? No, I said that plants may. Dude,
Hold on, let
are you
him
a liar?
finish. All right, let each other finish, please. Let's hear the conversation.
So it's just shocking to me that they try to make the claim that, photosynthesis doesn't involve carbon dioxide because people all over the planet are supplementing their gardens with carbon dioxide.
Okay, let me comment to that. Okay, plants one more time. Okay, I think that we can demonstrate plants absorbing carbon dioxide. It's just an effect. Okay, it's basically an effect. You have a gas. Okay. And by doing different things to it, you get different parts, the way they word it, you get different elements that compose air around us. Okay. I can go with that. The first thing I said is that plants may absorb carbon dioxide. Okay. It could be the water from the plants are filtered, funneling that's absorbing the carbon dioxide. Wouldn't you say?
Well, I don't know. It seems like the photosynthesis formula is well understood. Carbon dioxide is one of the limiting factors, right? If you look at that formula, it's the one thing that you can increase. Once you have optimal sunlight and optimal water, then the only thing you can really increase to increase yield or the plant growth is carbon dioxide. And there's just a lot of
citation for that.
That'd be easy to prove, wouldn't it? So go ahead and try and prove that, and see what happens. Put a plant in a big ass jar.
Guys, the proof is in greenhouses where they actually monitor the amount of sunlight that comes in, and they actually adjust the amount of carbon dioxide and water that the plant receives based on the amount of sunlight that the plant receives. That's how fine-tuned the science is.
Yeah.
So then you should have no trouble proving that. Then you should have no trouble showing us a plant convert carbon dioxide and oxygen. Right? Should be very easy.
Well, what I can show you, Brian, is try to grow a plant without carbon dioxide and see how it
It
goes.
most likely converts it exactly how the body converts
Oh, Matrix,
your
it's still
food
no
to-
good.
Shit.
It's like you're talking through a pillow.
You guys know about the Hill reaction, right?
No, what is that?
It's the plant takes water and breaks it down, and that's where it doesn't take in an oxygen or a carbon dioxide and spit out an oxygen molecule. It doesn't like convert it inside the plant or something. That's not how it works.
All right, how about now?
Yeah,
Does
now
sound
you're
better?
good. Yeah, that's good.
All right,
How does it work, Jeremy?
Let me just explain it before the mic goes to shit again, right? The way the plants convert things into gases the same way your body converts things into farts, right? You eat the material and the inside of your body converts it into the gases, and then you excrete the fart. The plant does the exact same thing. It's close.
It's like farts.
Okay. Yeah, that's how I understood it.
Because the plant, hold on.
Just breathing in
Plant
plant
also
farts.
eat- No, the plant also eat light.
Plants eat light.
Yes, without
Or
light,
do they?
none
Or
of
do
this
they
will happen.
simply absorb
None of
certain
this will
types of
happen
yeah,
without light.
fire? Maybe the light
They
baths.
don't eat fire, do they?
Hold on, guys. Too many people talking.
Well, they claim that the sun is a nuclear
right?
Hold on, Brian.
We eat farts, right? We eat food, and our body converts the food into farts. That's what I'm saying about the gases in the plants.
Yeah, no, I get it.
Are you
That makes sense. Gio, you were gonna say something?
No, I was just trying to make a joke. I was asking Matrix if he's a fart earther now.
Fart Arthur. Hey, Brian, a couple people are asking you for any kind of resources you can guide them to about your position on this one.
Go to Peter and Pete. Peter and Pete, they just did one on photosynthesis with demonstration. Okay. Like I said, on this channel, we like demonstrations. Okay. We don't always have, but we do our best to offer demonstration, repeatable science. Okay. Whatever you want to call it, tests. Okay. We like to see shit. We don't like rhetoric. Okay. We do our best with the rhetoric, but it falls back on showing shit. Put your money where your mouth is. Don't just speak what you learn.
I watched that episode, and really all they did was analyze someone else's experiment, right?
When was it? Wait, can you tell me when it was?
The one they put out this morning.
Okay. How many have they done? And so are you trying to claim they haven't done demonstrations with photosynthesis?
No, but I'm saying you were saying that they did a demonstration, and I'm saying
Yes,
no,
several.
they analyzed someone
A
else's
whole
experiment.
playlist, bud,
They
of
analyzed someone
videos.
else's.
They've got a whole playlist of videos. Okay, they've obviously have backgrounds in chemistry. Okay, so they know more than me. Okay, I understand what I was taught. I understand what's in the books from years and years ago. Okay, slowly updating to conform. I also see that, like everything else, it's veering away from reality as they try and keep the conformity.
So regardless
It's
of
electric.
cause and effect, right, or non-cause and non-effect, are the ballers trying to say that cycles don't exist, whether
Yeah, that's a
above
good
ground in the
question,
air
Aaron.
or in
Yeah.
the ocean? Yeah.
Bring it back, because that was why are we even arguing about this?
Yeah.
Well, to show you that it's electric. Okay, so it gets the sun gets. Hold on. Get the electricity from the sun. Okay, take some trees or plant and shit, burn them. Get the ash, the coal, the charcoal, whatever. Okay, get the burnt ash, and then just put it next to steel. Okay, and put a positive and a negative electrode, and then bam, you get your electricity back. It's all a cycle. Mother Nature is a great big cycle, man. Everything's
no.
electric, man.
My question was, why are we arguing about whether there is this gas cycle or not? Why are we arguing about whether this stuff happens on ground level? What does this impact when it comes to the shape of the Earth?
Yeah, they couldn't, and also they couldn't prove you know, just the basic common sense and things we see and demonstrate. And so they went to just spouting off bullshit, talking about, you know, trying to contest gases and where they come from. It doesn't prove anything about the shape of the Earth, but it's a whole you know, paradigm that needs to be modified, in my opinion.
Well, isn't the question always why is there pressure gradient?
Yeah. Does this explain why there's a pressure gradient if these gases are cycled at the ground level?
Are created at
Well,
the
you would
surface,
expect there to be, if you have introduction of a gas into a system, and the gas is being introduced and used in that same general vicinity, you would expect that that's where you're going to find the most gas at, obviously.
And let me ask you a question.
I remember Brian began with an experiment that, according to his word, occurred spontaneously. Yes, it's a matter of fraction of a second for the pressure to equalize. Yet the pressure in my room is
no.
What? No, what?
No, dude. I demonstrated. I demonstrated a temperature gradient. Chikey, look at any gas law. Okay, it's called a temperature gradient, bro. Okay, look, you take a big jar. Okay, and a bladder in it. Okay, so the bladder. Listen, the bladder. Hold on, the bladder fills half the jar, right? So you got a big jar. Okay, however big you can picture it in your head, but picture a bladder that fills half that jar. Okay, the top or the bottom half. Fill that bladder with hydrogen, okay? It's going to go to the top of the jar, okay? Is there going to be a density? Is there going to be a pressure gradient? Is there going to be a density gradient? Okay, tell me what there's going to be, Chikey. Let's, you know, think for yourself one time.
I didn't get what you say.
I know you didn't. Okay, picture any size jar. Now picture a bladder in that jar that fills either the top half or the bottom half. Just a thin plastic bladder, okay? Now fill that bladder that fills half of the jar, either top or bottom, with hydrogen, okay? And it's going to go to the top, right? Is there going to be a pressure gradient in that jar? Is there going to be a density gradient? What's it going to be?
Both.
Yeah.
Okay, so right there in 2 feet, we're going to have a gradient, right? So that's my point. I showed a pressure gradient inside containment.
No, you haven't.
Okay. Yes, Chike, you can do it yourself, bud. It's real easy. It's
Brian, you never measured no pressure. You never measured pressure.
Yeah.
You want to say that the pressure that is 0.1 psi, whatever, at the top of or 20 miles up, okay? So shouldn't the gas start rushing up there according to you and your pressure gradient?
According to you, it should rush up.
Yes.
Okay, well, but I demonstrated that it doesn't. I demonstrated for everybody to see in 60 or 70 feet that heating up one side of a 70-foot run of pipe and a boiling water on one side at the end and an ice cold water at the other, you get a small pressure gradient and only 60 feet, bud. It's called gas law, bud.
You measure that.
You've got to constantly pump energy into it to maintain it. Okay, because nature's going to try and equalize. Okay, it's a dynamic system, and as long as I keep boiling water on one side and ice water at the other, it will maintain that small temperature gradient. It's a pressure gradient. It's gas law. It's well known. Okay, you're just trying to connect it to your outer space paradigm, and that's where it breaks down.
Bring the gas law. Bring the gas law that has gradients in it.
Once again. Okay, the colder shit is okay.
It's not the gas law.
I don't even know where. Somebody help me out with this. It's like talking to, just born super blemish.
Even know where gases came from 10 minutes ago. Now he wants to talk about gas laws.
No, we never said where gases come from.
It's like, okay, PV equals nRT, okay? So what does that mean? In a given volume, wait, don't ask me a question and cut me off. If PV equals nRT, okay?
Where's the gradient?
That's ideal gas law, okay? Okay, sure. So if in a given volume, okay, the pressure is tied to the hip with temperature, would make a gradient in a given volume.
Where's the gradient, right?
Where are you getting your pressure? You don't even have the volume, dude. Dude, you're slacking, bro. I'm sorry.
Where's the
We said
gradient in
TV
PBS?
equal NRT. Where's the gradient?
Do this at home. Go get you 70 feet of PVC pipe. Boil like a trough at the end, and stick the end of the pipe, the last 5 foot, in boiling water. Put a balloon on the end. Okay, loosen up the balloon a little bit. Okay, now on the other end. Okay, put a trough with ice water. So the last 5 feet of the other end is going to be ice water. Okay, what you'll get is on the hot side, that balloon will blow up a little bit, and on the cold side, it'll just sag. You can do it yourself, bud. You're not limited.
Yes, especially if you use two
And I'm not the only one to demonstrate.
Especially if you
Okay?
use 2 different balloons, Brian.
So you're telling me that gas is not volume dependent and temperature dependent? Is that what you're trying to tell me, Chucky?
That's what he's saying, dude. That's what he's saying, dude.
Temperature changes, pressure, different things like that in an isolated system.
Howard, what does that mean? TV equals NRT. What do you think that means?
In an isolated system, it just represents the relationship of pressure and volume and how much gas you got and temperature in an isolated system.
Right. In a closed system, correct? A closed system, correct?
Yeah.
Absolutely closed. Otherwise, you'd lose energy, and that can happen.
Closed or an isolated left lane?
Oh, I would just say closed. I wouldn't say isolated.
You're roboting.
It may be.
Yeah, it's coming
I would
in and out.
have to look it up, study it. It's been a long time since I've studied this.
This is sixth grade science.
Yeah, because you mixed up isolated and closed. Yeah.
All right, let's say there is a gas gradient. There's a gas gradient in the atmosphere. So what?
Exactly.
Why?
Exactly. So what?
Why? Why is the gradient there?
Because not all gases love other gases, dude. Right? Some other gases
gradient, not a
love
pressure
to hang
gradient.
out, like Travis just said. Hey, buddy, let's hang out over here. Okay, and so they form more of a more dense gas, right? Together, a molecule of gas, let's just call it, right? And the other gases that don't like hanging out with those gases, they get fucked off.
They like to confuse density with pressure. They love doing that. So they can keep their refraction and everything else.
Howard, 2 things. Temperature and pressure. There you go, buddy.
Yep.
But does anybody
Except
have an
our
answer to my
atmosphere-
question? Well, what is this? What does it matter if there's a gradient or not?
They just heard that somewhere, and that's what they repeat.
Well, the ballers always claim that that you wouldn't have that without gravity.
That's right.
Gravity
makes no
does
matter,
not
right,
do
Howard?
jack shit.
Wait,
Gravity
real
as
quick.
in things fall down towards the ground.
Yeah, just
as in volume of air above you is pressing down, causing the pressure.
You mean the PSI? It's just pressing down. It doesn't press outward or upward, or the PSI doesn't do all that. Howard?
It's omnidirectional.
It's omnidirectional, just down. PSI is just down.
So Howard, why can't you have that on a planar stationary Earth with quote unquote gravity just pulling things down to the ground?
Yeah. Let's give them gravity just for this
Why
argument, right, Gio? Okay. There's gravity. Things
I
are
get
pulled
gravity.
down by some force.
Yeah, you could.
Right.
If you had a flat Earth with gravity, there would be a pressure gradient. Yes, there would.
Okay. All right.
Gravity's not a force, according to
All right. So that goes into
And the second after, the flat Earth would turn to a sphere.
Oh, you're better than that,
Oh,
Chucky.
really?
You're better than that.
That's a fact.
I'd like to defend. Our cause too, man.
So left lane. Yeah. This cone of gravity, air pressure is pushing down on me on the PSI per square inch on top of my table, right? It's right there. Does it stop at the top of my table, or what happens if I put my hand under the table? Does that PSI still get me, or did my table stop it? Because you can measure PSI on the top of my table and the top of my hand.
In the middle of your room.
And the middle of the middle. Okay, cool. So it's not
laying on
omni.
the ground.
It's
It's
not
not coming
omni.
from underneath. Right? It's squashing him if he's laying on the ground, flat to the ground. What if you put a bladder of water flat to the ground? It's not squashing that water. Here's the thing, okay? The thing is okay, we can see, okay, based on reality, solid objects, okay, on average fall at 9.8 meters per second squared due to disequilibrium. Period. That's the only thing we can prove.
No, they don't fall at that rate.
Obey
Negative.
that, okay?
That is not true.
Well, to
They
get
only
something in
fall
the
at
air,
that
you have to
rate
put
in an
energy into it.
idealistic fantasy condition. Let's be
To
clear
get
on
something
that.
to fall, though, I will say this: to get something to fall, you've got to put energy into it and lift it up.
You got exactly. Things don't just fall.
And the energy
So
we're talking about with
downward
gases,
force it's not necessary. Okay,
the energy
It's
we're
not
talking about
necessary.
with gases and water is pressure and temperature. That's energy. Okay.
What if you knock a glass of water off the table?
To get buoyancy, you got to put energy into shit. You got to.
How'd the glass of water get there, Howard?
Sit it down from the sink. You fill the glass of water up and you set it on the table, and then the cat comes along and knocks it off, and it falls down.
What if you step on the gas and get out of the left lane because you're getting passed on the right lane by a Kia? Move over, Howard. Move over.
It always holds potential when it's got height.
What kind of potential?
Yeah.
I tried, Travis. That was funny.
Potential to drop because it's not in its equilibrium layer.
I don't know of such potential to drop energy. Never
Such
heard of it.
simplicity. Wow.
I
Can't.
think
It has
people
to be
get
harder than
confused
that.
about a little bit about what Gleam just said about it always has potential, because I hear some people say stuff like, when you pick it up, you give it the energy. And it's not like you're transferring energy into the object. You're just moving it from a position of equilibrium, and it now has the potential to become in a state of disequilibrium, which will cause it to fall, right?
Right. I didn't mean to reify energy, but I mean you got to use energy. It takes, you got to use it to get something off the ground or something light underwater. Something.
When it comes to relative density, we're the ones that have the upper hand. We have the science for this. They have make believe space time bullshit. We're the ones that can. We're the ones that hold on. We're the ones that can have an independent variable and follow the whole scientific method. Hold on. You know what? Go ahead, guys. Go ahead.
Yeah, no.
Jeremy's right. Jeremy's right. You guys talk about bending of space-time and all this shit. You guys got a fantasy. You've got a story. All we're talking about is what empirically can be observed and repeated via experiment. We don't need anything else.
Yeah. Just because a guy wearing a white coat doesn't make him a scientist.
Exactly.
Reality, Chaiki. Reality.
Yeah, but what happens if you wear
Chaiki's over on when Chaiki goes to a different panel, he's going to sit there and talk about, or Howard, or maybe they're buddies. Okay, they're going to say that we are science deniers and like we deny the math. Once again, just so y'all can drop this from y'all's argument, we do not deny the math. Reality shows that solids in air fall at an average rate of 9. We witnessed the acceleration. Okay, so objects fall at 9.8 meters per second.
That's because you've taken. They fall like that because you've taken. They fall like that because you've removed all the drag. There's no reason
Yes,
why
that's
that.
important, Brian. Don't repeat their fantasy. Things do
Well,
not
they keep
fall
saying
at
that.
that rate, bro.
You've
the math
removed
is
the density.
demonstratable.
Yes.
You're saying that I'm arguing against the math, and I'm not.
You've
Brian,
removed all the drag. You've changed the
things do
density
not
of the
fall
medium.
at that rate. Do you understand that, Brian?
You've
You removed all the drag.
Go ahead, Jeremy.
Well,
You removed all the drag. You've also changed the medium of the density of the medium to the lowest we can possibly make it if you're talking about a vacuum. So anytime they invoke a vacuum, we won. You change the medium, we won. You just prove relative density.
Where's the relativity in the vacuum? Where's the medium in the?
What, Howard? What?
Oh, not this. Come on, Howard.
I know where it is. I know where it is. Something is relatively more dense than nothing. That's where it is.
Hey, y'all don't get tired of hearing them saying that we deny the math.
Ingenious,
to demonstrate.
ingenious.
Well, okay, if we can figure out, how ball's going to go, all this shit that we can easily demonstrate. I'm not. My whole point is I'm not arguing the math, and I'm not arguing reality. We see things fall at a certain rate, accelerating at 9.8 meters per second due to disequilibrium. That's the only thing we can prove. That's all we need.
Yeah, it's just not exactly that number, and we don't have a perfect vacuum. Yeah, there's those caveats. I understand where SE's coming from, but in general, they know how to calculate it, and they have the right calculations.
Crit just said that not all
No. It depends on the disequilibrium. I didn't never say how much disequal shit was.
There's no
In other words, shit might not fall at all.
Mailman has been trying to
Depending
talk.
on the disequilibrium, if it's equal, hold on, dude.
No, it's not.
It won't fall at all if it's equal. Hold on, if something is equal, and
What
it
is
won't
equal?
fall at
You
all.
have to talk about the thing that you're claiming
The
is
density,
a
bro.
disequilibrium.
The density,
What
jackass.
are the two properties you are claiming are not equal?
Density disequilibrium. Okay.
Right. Well, the density of the air above a ball is just the same as the density below the ball. So why doesn't it go upwards?
Rumpus, do you have a white lab coat at all in your closet?
I do.
Because
Okay,
the
well,
law
you're not
is
a
that things
scientist,
go,
Crit.
they order
You know,
themselves
Crit just said that not
according
all
to their
scientists
density
wear
on the
white
face of the
lab
earth, Rumpus.
Okay.
That's what it is.
What was that, Drivel? Sorry, I didn't catch that.
Rumpus has a white lab coat. That's funny as shit.
What was that piece of ridiculousness you just spouted?
It's not ridiculous. It's just an observation. Things order
is an
themselves on the face of their earth according to their relative densities.
Hey, everyone.
No, if that was the case, they would fall at different rates. They don't.
No, it wouldn't. Why would they fall at different rates?
They do too.
In a vacuum,
I can show you right now on camera. They do.
It's medium dependent how fast they fall. What are you talking about?
Mailman wants to get in on
The
this.
density of the object makes no difference at all as to how quickly.
Okay,
they
that's
Why
great,
would it?
Rumpus.
Why would it?
Mailman wants to get in.
Well, you claimed it. You just claimed it did.
No,
Yeah,
I didn't.
Mailman
You
wants
said
to
that
talk.
you made that
Y'all
straw
give me
man
this
for me.
man one second.
Well, okay,
After Brandon.
I didn't understand what you said then. You said something about the relative density.
Okay, yeah. Okay, great, Rumpus. You talk all the time. Mailman says he never gets a chance to talk. Let
Yeah,
Mailman
go
Give
ahead.
me one-on-one after Brandon. After Brandon, give me one-on-one with Rumpus for 1 second. I could easily disprove his hogwash.
Hold on, mailman, go ahead.
No rush. No, I can go later. It's okay. Let Rumpus speak.
Okay, now according to Rumpus, okay, he's saying in a vacuum everything falls at the same rate. Okay, but when we put the water balloons in the vacuum and started in a chamber and started evacuating the gas, okay, when it got down a hell of a vacuum, okay, two of the balloons exploded. There's one left that could withstand it. It barely dropped. Okay, it barely went down, barely, slowly. Okay, now if you're going to tell me that a lead ball is going to fall at the same rate as that helium balloon in a vacuum, bro, you got no common sense. You were born with a blemish. So
Well, this just means you're a moron and a science denier, because that's exactly what happens. And if you remember the Brian Cox experiment, he had a lead ball and a feather, and they fell at exactly the same rate in a vacuum chamber. And every single test that's ever been done proves that.
We can't trust Brian Cox. So Brian Cox is your scientific experiment that you're putting forward to support that.
I said in a vacuum. Who's asking?
Oh,
me
what was the medium?
Brian
I just
Cox
said a vacuum.
video.
How many times do I have to say that?
A produced video.
Who's asking?
Rumpus is your experiment that you're putting forward. Brian Cox produced for TV video that has multiple cuts in it.
Who cares how many cuts? It's got
Because
in
they
it?
fake shit for those kind of programs. We busted them multiple times.
That is scientifically established. That was done to produce. They don't think there are morons out there who
It
deny
wasn't
this. They were just
scientifically
demonstrating
established. He's a science communicator. He's not a fucking scientist.
Oh, he is. He used to run.
Well, that's
CERN.
what he was
used
at.
to run part
No,
of
he's
CERN.
not.
He used to run part of the CERN experiment. He's a very
Not when he's making a fucking
reputable
TV program that's produced.
No, that's what he's done subsequently. He was in charge of a massive billion-dollar experiment in CERN.
Do you have an actual experiment outside of one produced for television for a science communication program?
Tyson. He's actually run
for God's sake, guys.
huge
Okay, so if I put a balloon, hold on, Rumpus. If I put a helium balloon in a,
I'll
in a
take that as a
chamber
no,
and I
Rumpus.
evacuate half the air,
He is a scientist.
hold on,
He's
if I-
run
oh my
huge
God, dude.
experiments. If you're denying that, you're just denying basic history.
Rumpus, if I put a helium balloon in a vacuum chamber, if I put it in a chamber and I evacuate half the air, okay, and the balloon is still floating, half the air is gone, but the balloon's still floating, and it still has a little bit of lift. So I can weigh.
Who cares?
Let me finish.
We're not interested in half a vacuum. We're interested in a whole vacuum.
Half a vacuum. Okay, and as we get more and more.
Irrelevant.
Okay, what's the point that the balloon starts racing down at 9.8 meters per second squared? And what is the phase? If you don't care about that, at what level? Okay, because as I'm getting closer to a vacuum, the lead ball is still racing down. The helium balloon is still floating. It's still lifting shit up.
If you don't have a full vacuum, then you have buoyancy issues. So if you want to eliminate the effects of buoyancy, then you have a complete vacuum. If you do not have a vacuum, you have buoyancy issues, and then you confuse the issue. And people like you get confused. Having a vacuum and then everything falls at 9.8.
Not sure it's an issue, Rumpus. Not sure it's an issue. It's just
Rumpus. It should be a gradient.
Well, we understand buoyancy, but for simpletons, buoyancy confuses them because there are two effects, and flatties can't cope with more than one effect.
Yes, we can, bro.
No, you can't. You can't cope with two effects happening at the same time. It's beyond your intellect.
No. That was you needing an extra fucking equation because you got to have your gravity. Okay, I've already explained why things fall at 9.8 meters per second.
In a vacuum, everything falls at the same rate, and so
Can we pause for a minute? Brian brought up an interesting scenario, and I want to get a real answer to it. Let's see if we can get a real answer to this, and then we'll go. Jedi, we'll let you come in. So you've got the balloon, you've got the chamber filled with oxygen, you've got the lead ball, and you slowly suck the air out.
Okay.
At what point does the balloon just start to fall at 9.8 meters square down?
Well, only because there'd always be some buoyancy effects. I mean, for instance, if you weighed a lead ball in the atmosphere, there is a small buoyancy effect on the lead ball. It won't quite show it. Wow. God, can I finish? It doesn't quite show the complete weight. So, for instance, there's an American institution for measuring weights and measures, and when they weigh even vast objects, they do it in a vacuum to ensure there are no buoyancy effects. So even a lead ball, So even a lead ball is subject to buoyancy. So you want to remove all of the air and be in a vacuum to measure something's genuine weight.
Kind of like Wolfie did, right?
So I'm gonna suck the air out, and eventually the balloon is gonna fall at 9.8 meters per second squared, same as the.
It never falls.
But not until I get all of the air out.
Yep. Yes, otherwise you have buoyancy effects.
Okay.
All the balloon does is lose its lift. It never falls. It barely trickles down
it does.
when the vacuum gets closer to zero. It's never dropping at 9.8 meters.
If you were to show that something did not fall at 9.81 meters per second in a vacuum chamber, then you would have the whole of science jumping up and down and coming around to see you.
They should be kneeling in my fucking feet, dude.
All right, let's let Jedi go. Go ahead, Jedi. Jedi.
You don't have to worry about it.
Hold on, Brian. Rumpus.
Shut up.
Jedi, go.
You took away the medium. Sorry, Brian.
All right, I'll type. Right, so I understand, balloon with gas in it falling in the vacuum. Most balloons that I've ever seen filled with gas in a vacuum start to expand. So I'm starting to worry about these balloons that are being dropped. But the thing is, when the gas escapes,
they'll expand and they also still fall.
Yeah, but when the gas escapes the balloon, it then fills the next available space, which is then the vacuum it was in, right? It's all well and good dropping solid objects, but we're talking about gas. And the gas will fill the space.
If it doesn't go into the chamber and it's contained by the rubber, then it will fall at 9.8. And all the gas molecules will do the same thing.
That's a really good point. Yeah, that doesn't prove that gas falls.
No, stop.
Go ahead,
all the
Jedi.
gas molecules don't do the same thing. The gas doesn't just stop and fall to the ground.
Yes, they do. And then they
lay there still.
They're like bouncy balls. Just as I think, if you throw a ball up into the air,
you are just a fucking
If I were to throw a ball up into the air at 500 meters per second, which is with the average velocity of gas in the air, it will, like a ball, if I throw it 500 meters per second upwards, it will.
And then the ball stops. With the gas doesn't stop. The ball goes down and up and down and sideways and all around the thing.
The
It never stops moving back and forth. It doesn't just fall and stay still.
Way
You
as
fucking
a solid ball thrown
I
up.
can't. I literally can't stand you.
Rumpus, quick question.
You'll never see
Rumpus.
Well, let Jedi finish
Rumpus.
going back and forth with it.
Too many people talking.
I need to watch my
Rumpus.
apparently.
If y'all would have just gave me a minute, dude, I would have destroyed it.
Hold on.
Never see gas.
Jedi was going back and forth. Just let him,
Can you tell me
please
the
let them
direction of
go
the
back and
gas in the
forth.
balloon?
I didn't hear the rest. Do you want to
Tell
say
me
that
the
again,
direction of the gas in the balloon, please.
Well, it goes in all directions, but it's pulled down to.
Thank
pulled
you.
Down to the, yeah,
And that's
it's
it. Job done.
accelerated.
The gas is
Yeah,
going
but
in
it's
all
accelerated
directions.
downwards. Yeah,
Thank
if you
you.
just held the gas
In the
balloon,
container of the balloon, and when the balloon is no longer there, the elastic, the gas will go in all directions and fill
but it
the
will be
next
accelerated
available
downwards. There'll be a
space.
preference to go
No,
down.
there's nothing to
Some will
accelerate
go up.
downwards. It's
Just
not
try
contained by
listening.
the
Try
balloon
listening.
anymore. I've removed
So
the balloon.
try listening. The
No,
gas
you
molecules
try
will be
listening for
going in
once
all directions.
in
Try
your
listening.
long,
Give it a go. Give it a go.
life,
Try and
Rumpus,
understand a bit of
please.
science for once. Try and understand a bit of science.
This
When you
isn't
start
science.
off, try.
Rumpus,
Give it a
what
go.
the fuck are you doing, Rumpus?
Guys, chill.
What are you doing, dude?
I have a very quick question for Rumpus. So, say we have a very precise gravity meter or gravimeter or whatever you want to say. So, let's say we have this gravimeter and we're at the top, like there's this really massive industrial complex. Okay, it's like a huge fucking place made of cement and whatever. You're at the roof. You're on the roof, right? You get this reading from this gravimeter. And now, if you go down to the basement, like the huge complex is all above you, and it's heavy. It's a heavy, massive fucking thing. Shouldn't there be a difference in terms of the gravimeter's thing on account of gravity because there's less mass now to attract it? It's attracting upwards a little bit.
Yeah, there'd be a very, very tiny effect, but they'll be too small to measure on a gravimeter. I mean, if you have a mountain, for instance, one of the alternatives to the Cavendish experiment was setting up a pendulum next to a mountain in Scotland. I keep on forgetting its name; it's very difficult to pronounce.
Mountain
And then it will actually cause the pendulum to swing very, very slightly, and that is just about measurable. So you'd need something the size of a mountain. For a gravimeter to take. Obviously, the Cavendish experiment, which is using
No, I don't want Cavendish because Cavendish is side to
Hold
side.
on.
But you will get a tiny effect, percent. You would get a tiny effect, but it's probably not big enough to measure. You need a mountain. You need to go down.
Okay, let's say we have a mountain.
How about this? Get in a mountain. Go and drill a tunnel under a mountain, and then you would be able to see a tiny effect, probably measurable by a gravimeter.
Hey, Rumpus, can I just interject for 10 seconds?
Citation for that? Sorry. Go ahead, Terry.
Yeah, one quick thing for anybody on the fence out there. Gas will ever fall at 9.8 meters per second, ever.
Hey, Brian, can I just interject? Because I think there's something that the flat earthers aren't getting
They're
here.
just like bouncy balls. They just behave.
Hold on, Rumpus. Hold on. Terry's
like
trying to
bouncy
speak.
balls.
Terry was trying to
Hang
speak.
on, can I just say something for 10 seconds?
Yeah, go, Ru.
Yeah. I think what you guys aren't getting is if I throw a ball up in the air, it is still accelerating downwards. Do you
Gases are solids. The ball's a solid, you dipshit fucker.
They're the same. They're the same. If a gas
You're
molecule
an idiot.
is
They're not
going
the same.
up,
Solids and gases are the same. You're a retard. You're the dumbest person on the panel right now.
if a gas molecule is moving upwards at 500 meters per second, it is still accelerating downwards at
Technically,
9.8.
it's decelerating.
Well, no, acceleration's a vector.
Negative acceleration.
Technically, deceleration is not an actual term.
When it's called accelerating downwards. What?
Do you guys understand that it's moving up but accelerating down?
So when I hit the ground, I'm still accelerating. I'm getting heavier and heavier on the scale.
I mean, this is something that QE doesn't understand, that you can have a velocity in one direction and accelerating another. And the fact that
So QE would nut you, dude. QE mudded you in your last debate. You didn't even know what science was, bro.
Drew have just described. You can have acceleration and velocity in different directions. I would suspect most. Well, I wonder how many of this panel understand that.
Okay, hold up, Rumpus. You can have acceleration, right? Can you also have deceleration?
Nested reference frames.
Deceleration is just acceleration with a negative sign. There's no.
This has already been settled, Rumpus, right? So at ground level, if I were to dig down 1 mile, I dig down 1 mile, what would I weigh, right? I'd weigh less than I weighed at ground level, right?
Correct.
Okay. Now, what if I rose up in the air? You know, from ground level, I rose up 1 mile. How much would I weigh? I'd weigh less, right? Because I'm getting further away from the center of gravity, right?
Good point, bro.
Okay. This has already been settled, Rumpus. You talked about this for fucking years already.
It's not that good of a point, though.
G is only at ground level.
It is also an average, too.
So what point are you trying to make? You just repeated something.
G is only at ground level. That's it. That's where you get your G.
Yeah, they say
Look,
G
I
changes.
say something.
The value of
Oh,
G.
the point is Rumpus was
is
one with a
only
blemish.
correct at ground level. If you were to go down, dig down, as you said, G would get less, and if you went above in the atmosphere, it would also get less. Yes.
Okay, cool.
No, I get more.
Okay,
But
Look,
Rumpus or Terry, can you guys
let me
explain
say
to me
this.
how you can have something
Let me-
slowing down as it's going up, and that's
No, you
acceleration?
see, again, you're matching velocity. You don't seem to understand the difference between acceleration and velocity.
It's decrease in velocity.
Can you guys give me 30
He's
seconds?
still on
Velocity and
deceleration,
acceleration
Rumpus.
are different things. For
I
instance, if
know,
you're in a
I'm
car-
saying the
I'll
velocity
give
is
you a solid
decreasing.
example. I'll give you a solid example.
Rumpus, hold on.
Rumpus,
Before you do
I'm
that,
gonna
I'm
give
not
you a
saying
solid
it's
example
velocity.
if you
I'm
shut
saying the
up.
velocity is
I'm going to give
decreasing.
you an example if you shut up.
Lord have mercy.
If you're in a car...
Is it the same as conservation of momentum?
Shut up, twat. In a car, you're going along 60 miles an hour. You start to brake. Right, you're still...
That's what I'm saying. Conservation of momentum.
Shut up!
Fucking
Shut
idiot.
up, twat! Shut up! Shut up! You're still doing... So you're going along 60... Be quiet, the twat is talking. 60 miles an hour in a car, and you brake.
Yeah.
You are still... Then you say you decelerate to 50 miles... You then change your velocity from 60 miles an hour to 50 miles an hour. Your velocity is still in the direction you were traveling, but your acceleration
Nobody's arguing that.
is in
Hey,
the
Rumpus,
opposite
shut up.
direction.
Nobody's
Therefore, the
arguing that.
acceleration is in the opposite
How's
direction.
acceleration
to
in
the
the opposite
velocity.
direction?
And
You're
the
just
same is true of a
decelerating.
Give me 30
gas
seconds,
molecule.
please.
The
Guys,
same is true of a gas
hold on.
molecule. That's
This is just a semantics argument. Acceleration is defined as
May
a
I say
change in
something, please?
velocity. It doesn't have to be positive. It doesn't have to increase the velocity. It doesn't have to decrease. It's just a change in the velocity.
But hold up. When I learned it,
I want to say something.
but when I learned it, when you have negative or positive acceleration, you're still accelerating
Am I
in
coming
whatever
through?
vector it is. It's just whether it's going down or up.
Just
Yeah,
look up the
the
definition of
acceleration-
acceleration. It's a change in
You can still have
velocity.
acceleration in
Hold on.
either regard.
Brandon,
when a
can
gas
you
molecule
hear me?
goes upwards, it's still going upwards, but accelerating
No, we can't hear
downwards.
Brandon, can you hear me?
Yeah, hold
you
on.
say that if the Earth slammed on brakes, we'd fly off at 1,000
What
miles
is it
an hour.
exactly that you're saying is accelerating
All right.
downwards?
Hey, Brian.
The uncontained gas accelerating downwards without a force applied to it. Show me uncontained
gravity,
gas
right.
accelerating
So
downwards.
when a gas molecule goes upwards at 500
Just let him explain himself.
So when a gas
What is it
molecule-
exactly that's
when
accelerating
a
down?
gas molecule is going up at 500 meters per second, it is
May I
accelerating
say
downwards,
something?
and its upward velocity, let's say it's going vertically upwards at 500 meters per second, it
Am I
will
coming through or
accelerate
Yeah,
downwards.
hold
and
on,
its
Silent
upward
Zero.
velocity, its upward
all right.
velocity will decrease until it gets up to about 60 miles up in the sky, whereupon it will reach zero velocity, although if it was left to its own devices, but it gets heated, it gets interacting with other stuff that causes it to increase in temperature. But in principle, if there's only one gas molecule and there was no sunlight hitting it, it would go up at 500 meters per second, pointing upwards, molecule would rise up to about 60 odd miles up, come to a halt, and then...
So windless wind.
and then fall
Windless
back down
wind,
to the
right?
ground because it's being accelerated to the ground all the time. Go ahead.
Well, in your model,
Which
doesn't
way's
it
the
get
Earth
hot?
going underneath this? Sorry, quick question. Which way's the Earth when this is happening going underneath this? Because the Earth is going in a
This shit is like
direction. The
8th
Earth could be
grade
going
physics,
up
people.
underneath it, towards it, or away from it, and definitely spinning underneath it. So what's the Earth doing underneath
Spin's
this when your arbitrary random claim about reality is happening?
Okay, I'll
So-
try to
Shit
understand
about
your
physics,
question.
dude. It's
So if
fucking
you
8th
said-
grade stuff.
The gas molecule is going...
Thank you.
What was
May I
that?
speak?
Ball game.
I thought he was
Yeah,
going
go
to
ahead,
carry
Silent
on.
Zero. Go ahead.
All right. I just want to say, Brandon, if we want to test relative density, right? What we got to do is grab a vacuum chamber, or a chamber, grab 5 or 6 different objects with different densities, and then the same chamber, we're gonna vacuum all the air, and then we're gonna put water, and then we're gonna put mercury, and we're gonna see the behavior of those 6 objects with different densities, how they're gonna behave. I bet you that with different density, they're gonna move up and down relative to the density of the object.
It's really simple. You guys
And
just
you're wrong.
wait.
You just made that
No,
up.
shut the fuck up, Rumpus.
You just
Shut
make
up,
it different.
Rumpus.
You just make
Please
stuff up.
mute him. He
He's not
wants
done, Rumpus.
he
He's
wants
not
to
done
interrupt me.
speaking.
He wants to interrupt me. So that's how you test relative density, right? We want to manipulate density. That's what we want to do. We have the same objects. We put them in different densities, and they're gonna move in different and accelerate in different manner.
No, they're not.
It's really they will.
You probably want to use different the same. You probably want to use the same surface surface area as well, because if they're different shapes, then they're definitely conditioning different medium.
Not in a vacuum, they won't. We were talking
Yeah,
about
but the vacuum you gotta. If you want to test the density, when you're removing the air, Rumpus,
You probably want to put
you're
the whole
removing
system on
the
a scale,
density. When you're removing air, you're removing density from the
Yes,
chamber.
but the
So
object, if
there's
you've got
no,
objects of
there's
different density
nothing
in there,
that
they
can
will
carry.
behave
Listen,
the same way.
Rumpus, I
So
wasn't
it's
done.
not dependent
There's
on the
nothing
relative
in the
density,
chamber.
because
Listen,
they will
there's
fall down
Rumpus,
exactly the same rate.
both
Rumpus,
Objects
there's
of different
Let him finish,
density
Rumpus.
will
Rumpus.
fall in the same way.
There's nothing in the chamber that can carry the object. There's no molecules. There's nothing. So you guys are hung up on this shit. You guys are so retarded. If you want to test and manipulate density, you want to first vacuum the chamber, and then you want to add water, which is a different medium, and then you can add.
You keep on saying this. You've said that, and you're wrong. You keep on
No,
saying.
I'm not.
You've now said it
Whatever,
4
Rumpus.
times.
You add water and then what?
You expounded your idiocy 4 times.
And then you take that's a different density medium, right? And then you add mercury.
I think what he's saying is to test the different densities. That's it.
Yeah,
He's not really
it.
saying anything. He's just saying to test it with different densities, so you could check what was the relativity of each of each one of the materials. That's it. That's all he's saying.
And
those 5 objects.
Those 5 objects. Listen,
Why
guys.
are you calling him a liar then? Then let him explain himself. It's very simple.
Those 5
understand
objects.
why anything's going up or down at
Ron
all.
Cox did that test in the vacuum chamber, and they all, but feather and a lead ball fell at exactly the same rate.
Brian Cox didn't do a fucking experiment in a vacuum chamber. He filled the fucking video segment. Find something better.
No shit.
Yeah, but you
And you're such a
What's that,
fucking
Graham?
cocksucker. Stop sucking these guys' cock, bro.
Do any of the flat earthers disagree with me?
That's on YouTube, and you still deny it. All
Yeah,
the
of
science
course, but I don't think relative density is in question.
All of the
You
experiments
know what
ever
happens
conducted
when
in
you
scientific
put
conditions
an
show that the
object
acceleration
of
due to
different
gravity is the same
density in a
vacuum.
medium.
Brandon,
We already know what
can you
happens.
mute this asshole? Just mute him, man.
Rumpus,
If
the
you
word
have a
don't
piece
lie.
of wood, right? If you have a piece of wood, right, and you put it on that chamber, right, it's gonna sit on the ground, and then we fill it with water. It's gonna accelerate up with the water at some rate, or it's gonna flow.
Why up? Why not down? Why not left?
Because the density
Why up?
dictates. That's what we're saying. The density
why is it
dictates.
vector specific,
Listen,
though?
then you ask a question. Then listen.
You're
Because
skipping the answer though.
No, I'm answering. Listen. You're not paying
Why
attention.
down?
You're telling me I'm not.
It can't be anything to do with the
Look at
density
these
itself
fucking
as to
idiots.
why it's up
Won't
or
let
down.
me
No.
answer.
You guys are misunderstanding each other. Maybe what Grim is saying is, why does the higher density objects go down in the less dense medium? Why don't they go left? Why don't they go right? Why don't they go up?
Let me answer that. Because
That's his question. That's one of their. That's the major thing that makes me think too. Is
Well,
why is there a
No, I know
direction? But then I
that,
think,
Brandon.
well, what else would there
That's
be?
where it all
There has to be a
started, right?
direction.
I'll answer.
Brandon, it could be any direction. If it was just willy nilly and there was no actual force that's fundamentally underlining,
Bro, it goes
then there
back
would be no
to where it
vector.
started, bro.
Hold on.
There would be no particular vector.
Does it go back to where it started?
Yeah, right. No, I get it. I get it. Yeah, that makes me think too that there's for some reason why there's this preferred direction per se. Why it down is down. I get that.
No. Let me answer that. Let me answer that. The relative density dictates where the object, how the objects are gonna move, either up or down. That's it.
No,
you don't need nothing else. You don't need to come up with any magical. I'm sorry, but you're
someone
just
please tell me. Someone please tell me why in the vomit comet the relative density changes when the airplane starts going over the parabola.
Because it's a disequilibrium. Okay?
No, it's not.
intense
It's still in the same media.
Listen, you're never going to give me an example of something not seeking its equilibrium, bro.
Okay, so tell me, the plane
It's
is still
because you're
going for the
counteracting the force that that tower
force?
is moving down in.
What force?
Counteracting
Down. So there's another
the
direction.
G-force. If it,
There's something.
if you-
There's something else
is a
besides
force.
relative density. Thank you very much.
Yeah,
Thank
of course there's a force because that
Drop your hat,
apparatus.
bro. You did
hold
it.
up, that apparatus
thank you.
is
Something other
force
than-
times the convention of mass multiplied by the acceleration that's going down, right?
Oh, so the acceleration going down called gravity. Thank you very much.
No,
Next.
you want to call it little g, that's fine, but it's completely
flat
dependent.
earthers into
That
trying to not
acceleration
believe
is
in gravity.
completely
Thank you very
dependent
much. So
on
there is
the
something
density of
besides
the
relative
object in the
density.
medium.
So, but the medium
in the
hasn't
plane,
changed,
it's
though.
in air, it's going
Guys,
down
there
in
could
that
be
air.
gravity on a flat Earth. You don't have to
Yeah,
hide
there's-
from
Let me
gravity.
tell y'all
There
what-
could still
No,
be
totally
gravity.
agree, Graham. There's nobody that doesn't believe in
Yeah, there is
gravity.
gravity
We
on a
all
flat
believe
Earth. Yeah,
things
there is.
fall down. We don't believe the story of space-time bending and there
Well,
being these
fine,
little
you're-
I'm with you. That's why
you deny
I'm
gravity.
with
You
you.
deny there's-
molecules or whatever the
I'm right
fuck
there
you
with
want
you,
to call
Brandon.
them, called
Downward force.
gravity, that are shooting out everywhere. It's just
If you want to
nonsense.
say there's a downward force and stop this relative density bullshit.
There's a downward
bullshit.
force
There's
for
bullshit.
things
Let me
that
tell
are more
y'all
dense
why
than their
there's a
medium.
downward
There's an
bias.
upward
Yeah,
force for things that are
No,
dense than the
that's half
medium.
right.
I would really
That's
like to
because
see the flat
airplane going
earthers.
over the airplane going over the parabola for the first half of the parabola is still going up. By
Yeah,
the way.
exactly.
Yeah, what about
Yeah,
the
so-
helium
Hold on,
balloon?
man.
What
Hold on,
about the
hold on.
helium balloon that's still in that?
That's
Hold
called
up, what about the
buoyancy,
helium
and we
balloon
have
that's in that
equations for it.
airplane?
We have equations for that. It's called buoyancy, and you should learn about it.
Yeah,
Yeah, when
I
there's-
really
when
would
there's
like
near-
to see
when
the
there's-
flat earthers, because then you wouldn't have to argue about buoyancy and all that shit. It's all regular, normal shit. The only problem
say
you
something,
have is
Brandon, man.
what's causing the. Can you excuse me? for a second?
Exactly.
What's causing the gravity? That's the issue. So
Right, I just handed you
and
your
you know
answer,
they
right?
can't prove it's space time.
Now I
They
got-
can't prove it's space time. Never mind.
Now I-
Okay, go
You're
ahead.
absolutely
Peyton
right.
Essenstial,
You're
you can't
absolutely
keep your
fucking
fucking
right.
mouth
We agree
shut.
on the effects. The cause is what's in contention.
Brandon.
Thank you. That's all
Okay,
I'm trying to say.
it's
Then
frequency,
that way
man,
there's
of-
like,
Hold on, Brian. These guys are having a conversation. Hold on.
seems like there'd be a little bit less, you know what I mean, animosity and argument, because I know most of the flat earthers do understand that there is. I mean, a pencil does drop when you drop it. So I mean, we can work with that and say that maybe it's not because of space-time curvature, obviously, because they can't hand us a plate of space-time curvature or make us a blankie out of some space-time fabric or anything. So they're not going to be able to, prove that. So we could just leave it there.
Yeah,
You
but
don't
that's
have
the
to
problem.
wait.
The
You don't have
globe
to-
earthers, they're always arguing. They bring up the effects, which we agree on, and they just like presume that it's caused by mass
I know,
attracting
but
mass
let's
bullshit.
finesse our argument then and start talking about, well, look at the problems with your proof of those effects. Because there's so many problems. I mean, we have light redshifting
That's what we
through
do.
plasmas, and they use the
That's
redshift
my
of light
point,
to
dude. I'm
prove
sick of them
Hold up,
saying
hold
that
up.
we're arguing
Hold on,
math.
so
Brian.
many different things.
We don't argue
And there's more
reality.
than
We don't
one
argue the
explanation
math.
Brian, let him finish, man.
There's more than one explanation for the observation, so we don't have to deny the observation, is all I'm saying.
Exactly.
But we
There
don't ever
might be-
deny
but
the
the
observations.
observation would be completely explained.
No, there definitely is more than, yeah. There's definitely more than one answer if they're choosing the other answer as the right answer, and there's this one that actually you can prove it does it. We can prove that
Graham, on
redshifts through a plasma.
On your belief
We
of a
can't-
globe Earth, what's causing this thing, gravity? On your belief,
Well, it would probably be a force like a scalable electrical force that's on the subatomic particle, and it isn't something that's registered on the I'm talking about the subatomic particles, quarks and fucking all this
Fermions
shit
and
that's right, yeah. That them together create a dipole moment, and so the mass of another mass is attracted to the two masses. It has nothing to do with being attracted to space in between or any space-time fabric, anything like that. It's actual intrinsic mechanism of the matter itself. Like
Look,
a
guys,
daisy chain. Like how
I've
a
been waiting,
magnet,
man.
like if you take a magnet and then pick up a whole bunch of different nails with it, and the nails will daisy chain and lock into each other, one nail after another, until it gets too weak, and then you can't pick up the last nail. Well, that's similar to the gravitational effect, except it's scaled up a lot.
Or until the current wears off that was used to create that magnet. Now, if we take a little pebble off the ground out of the middle of the mountain and we bring it up in the air, it's going to try and go back down to where the hell it was, okay, till something solid stops it. Now, if we take a bubble from the middle of up in the air and we put it in the middle of the mountain, it's going to try and work its way up unless something stops it. Okay, it's natural. Is this a false statement?
It probably doesn't need to be said.
Do pebbles have memory? Do pebbles have memory? Do they remember where they were?
Pebble in
No,
a
they
pond.
don't. But is this a false statement?
Water has memory, though.
No, it doesn't matter.
Water has memory of all the shit that's been through it.
The point is you can take water and it's something. If you heat the water up, something's going to sink until you evaporate all the water, and then it's just going to fall flat on its ass while the water rises up until it gets cold and drops back down again. We see this in nature over and over. Is it a false statement to say that solid objects fall at 9.8 meters per second due to disequilibrium? I say it's not a false statement. They say it's due to gravity. I say due to disequilibrium because we can do that.
Yeah, it's dishonest when globers say that it's not relative density. Like, it definitely, relative, even if you believe in gravity, mass attracting mass, it still adheres to relative density.
Right, I've said that many times.
No, it's dishonest when they say that we're science deniers and we're arguing the math and the equations that show shit falling at certain rates and going so far. They're being dishonest, and we've even got flat earthers. Shout out to Globe Bushers, I love him, but he wants to act like we're dodging the acceleration, the downward acceleration. That acceleration comes from putting energy into things, lifting them up out of equilibrium. Okay, we're not denying
that doesn't work, bro.
Yeah,
It's
you guys
also
just,
not
you
an
guys,
acceleration.
they just agreed that there is at least a force, whether it's gravity or whatever. There has to be a force because there's something accelerating. But you're
There's
saying,
always a
Brian,
force.
was
Not
like
an
a disagreement.
force.
What they were just saying that there is not a force and there's not an acceleration.
There's always a force, bro.
Obviously.
Even something
He's
in
a fringe flat
It's
earther.
sitting there
Let me
as a
give an
force.
example. Let me give an example.
Yeah,
real
there's
quick.
always a force.
Okay,
there's
so
a force if you take the
meters
question at the
per
end of the way to
second per
both
second,
in
right?
place.
Okay. All right. Okay, so meters. Let me give an example real quick about how gravity is not a force or an acceleration. Sorry. Okay, meters per second per second. Okay, we all know that one. How about hold on. How about miles per hour per hour? So let's say I'm going 60 miles per hour.
Shut the hell up.
Every
I'm so
single
glad that you're
hour.
allowed to talk
Every
uninhibited.
hour.
I don't know why
right?
he's here. Who is this?
Only going.
This is Aaron again.
miles
Yeah, I
an
figured.
Yeah. Right? So
Jedi,
miles
you were
per hour, right? Do you guys hear me? Right? Miles per hour. 60 miles per hour.
We're just waiting for you to stop. That's all. Go on.
Every
Yeah, you
single
can
hour.
just say squared
Every
instead of saying it over and
So
over
I'm
again.
going
Fuck.
60 miles per hour every single hour. I'm not accelerating. I'm just moving.
Yeah, you are. You're going. If you're traveling that, if you're accelerating that fast, you're accelerating. You're accelerating. You're accelerating. Jesus Christ.
Will
Brian.
somebody stop interrupting?
Well, look, man. Let me back it up real quick. Okay, they say if we're spinning at 1,000 miles an hour, the Earth slammed on brakes. If the Earth slammed on brakes,
Are you really trying to back what he just said up?
Is that
I
not
think
correct?
what Phase 1 says, that's the unifying thing that will unite all of globe earthers and flat earthers.
It's not quite, unreasonable though. Is the percentage right?
It's completely discounting what the premise is. The premise is that you're increasing the velocity by that amount.
But how do you get that from the equation? Meters per second per second.
If you're going
Squared, whatever brings that up.
Squared.
If you're going 60 miles per hour, you're just going 60 miles per second per second. You're going 60 miles per second squared.
Yeah, no acceleration at all.
Way. That's
No
acceleration,
acceleration.
dipshit.
No, but
No,
he's
it's
saying
not.
if you're going 60 miles per second,
He's speeding up.
every second,
No,
then
he
you're
doesn't
always
know his
going
math.
60 miles per
He
second.
just said, he's speeding up. Per second.
That's not what his
60
takeaway.
miles
His
per
takeaway is
hour.
like every second
Squared.
you're going that speed.
Per
That means you're
hour
maintaining that velocity.
Every single
Yeah,
hour.
but time
I go 60
dilation and
miles.
length contraction.
Yeah.
But
Every
the
second-
premise is the
every
context.
second you
Like
increase
the context
by,
is some sort of scenario where you're speeding up. That you can't forget that the premise is that you're speeding up.
There is no acceleration in miles per hour per hour.
It is. There is. If
Yes,
you're
there
speeding
is.
up.
Every hour you're going
Someone
60
take
miles
him to
per
the
hour
bank.
fast.
Can a flat earther please correct him? Can a flat earther please correct him? Because
I thought we were
anything
having
says
a good
he's not going
conversation
to
about
understand.
something
Can a-
substantive.
Talking at one time.
Okay,
Can a flat
so
earther
you guys
please
are saying
correct
that.
Aaron?
So miles per hour means that the first mile, or per hour, the first hour I'm going 60 miles, but the second
No,
hour
it doesn't mean
per
that.
hour
No.
I'm going 120 miles
write
per
me a check
hour.
for $60
Or
squared.
I'm just going
It doesn't say
120
anything.
miles.
Yeah, phase one. It doesn't say anything about your speed. You can be starting from any speed. It means you're increasing your
What's
speed.
an acceleration
By
if
60
there's nothing to
This one, shut up,
speed?
dude.
So,
Shut up. It'll be finished if you shut up. It just means you're increasing it by 60 miles per hour every hour. You're increasing it that fast.
Where's the
every hour.
function? Where's the function that does that?
In the
Go.
question,
Because you
That
said
is the-
per. You're using per in two different
two.
ways. The first time you're saying is
Oh.
how much distance you're going per
No,
hour.
no. The first
right?
time
And
I
then
said
you're saying
was
per
60
hour,
miles
as in
per
just-
hour.
Right.
Per
and then you're
hour.
saying- right. Now you're saying that you're going at a
Yeah.
constant speed per hour. Like you're using
Exactly.
per in
Yeah,
two
yeah,
different
that's-
ways.
That's the equation. Exactly.
Well,
Meters
the
that's not
equation.
what-
Hold
that's
up.
not what
Basically,
acceleration is.
so the equation is
That's
brought
not
up.
what an
You need to
equation
understand
is.
physics.
The equation
It's
is
not even
brought
what
up
an
in
equation
relation
is.
to a question. What's the question?
There is no
Thank you.
acceleration in the
No.
equation.
No, but there's a question like you
The
have
question
like,
would be, is there
someone's driving
acceleration?
down the road and they're increasing their speed. Calculate
The
the
equation,
acceleration,
the
right? And that's
equation
where you bring
literally
up the
defines
equation.
the acceleration. The equation literally defines
Hey, it doesn't
acceleration.
matter, dude. It doesn't matter. If you're driving down the road and you got a helium balloon in the car, okay, if you maintain that speed, the helium balloon is going to stay at the front of the car. Okay, it's going to stay
Yes,
opposite.
yes.
Even
If you
that
maintain a,
speed, dude,
a constant speed, but not if you accelerate.
if you accelerate,
Brenda?
it's
You're
going to
dumb,
move
dude.
to
That's
the
why
front of
the
the
helium
car.
balloon would go to the front if you accelerate.
If you accelerate, the helium balloon goes to the front of the car.
Front. If you accelerate, it moves to the front.
Right. That's where the
Correct.
force
Right.
exists
And if you
between
maintain
acceleration and
the front,
deceleration.
if you maintain
But you guys know why,
that
right?
speed,
It's
it will
because the heavier,
stay at the
denser
front.
nitrogen-filled air around it.
Is
pushed
I was
back,
gonna say that it's
and
not
the
because of
is,
there's
and
a
the
force.
air is displaced. The helium is displaced.
It's because the air in the car goes boom boom and goes to the
No,
back.
I'll
Okay,
explain why,
good,
Brenda.
good.
You're a little dummy. Let me
Good.
explain why. Because when you accelerate, the air moves to the back of the car. It becomes denser, so it's gonna push the globe to the front.
Exactly,
It's
because
really
there's a
simple.
force.
Again.
Yes.
Doesn't matter,
No,
dude. We're still accelerating the air
accelerating and
forward,
making
dude.
the.
Here,
No,
one
it's not
second.
that.
One
Oh
second.
my
It's
God,
this,
you guys!
and then
If you
say the
hear
same
someone else
thing and we'll-
talking,
Got
please,
that too, Grim.
please just fucking wait to talk.
Yeah, I would
I
just want to
did.
address silent. Let me address silent. Silent. So when you accelerate, no matter where you are, if you're going 0 miles an hour or you're going at a constant 40, when you accelerate, you're imparting a force in a particular direction. So if you're accelerating forward, you're going to have a force backward. So those heavier, the heavier material is going to move to the back, as you said, displacing the less
There's
the less
no
material
force
forward.
applied to that.
Hold on, man. So when you, in the same token, when you decelerate, what you're doing is slowing down. Even moving forward, you're slowing down, which means the force is going to be forward. So all those heavy gases are going to be pushed into the front, displacing the helium to the back. But it's because you're accelerating or decelerating, and you're imparting a force.
There's no force in the air. What
Not
you're
really.
doing is gathering
Yes,
the air
that
in the
is.
back of the car.
Same reason
No.
why helium
It's
balloons
the
float.
Why am I
velocity
gonna
of the
answer?
air
You guys don't let me.
changing.
Whatever.
You guys are all
Velocity of
agreeing
the air
anyways.
changing. That's
They
the
pretty
question.
much
Is
just
the
ruled you out.
velocity of the air changing?
Yes.
Yes.
Then there's an acceleration. By definition, acceleration is a change in velocity.
Yes.
Yeah. Is this in question?
Like I said,
How fast
everyone's
will we be
united
going?
against
Meters per
phase one
second.
on this
How
one.
fast will we have to
Well,
be
one
going to
person
slam
said
on
it's
brakes in the air and break this fucking windshield?
You know,
How
it's just
fast
not
will
an
we need to be
acceleration,
going for us to
right?
slam on
It's not-
brakes? If we slammed on brakes in the air, break the windshield. How fast will we have to go in for that?
You
to happen?
probably could calculate that. You probably could calculate it, but it's probably
You
going to be
think
some.
we can calculate that,
Hold on,
bro,
Brian.
but
I could get to the
you're
end.
not,
I could
because
get to the end of my statement. I could get to the end of my statement. So if we're just talking about the material involved, you can calculate the force needed for the mass of that object to
Okay, what about-
break the window on the front. You can calculate it.
Okay.
My prediction would
What
be
about-
that the speed,
circle. Hold on.
the speed
that same,
and the
that
sudden.
same vehicle.
I could get to the end, Brian.
Hold-
Brian, I could get to
holy
the end. It's
shit.
possible. There is a
I thought
universe in
my
which I
bad,
do.
thought this was the end. Everybody else, shut up.
There is a universe in which I get to the end, Brian. So you can make these calculations. I would
Don't
make
stop this one, Bio.
I would make a prediction in which the speed of the car would be too great and the
Yeah.
suddenness of the stop would be too sudden for anything to handle.
Yeah.
That's
Yeah.
my
One
prediction.
way to imagine.
Hold on. Now that's what I thought you said. Now, if we were going in a circle, how fast would we have to be going to break the side
Jesus.
window?
Why you
Come on,
insert
man.
new
What the
variables,
fuck is
Brian?
going on?
Why you do
I got
this
a point.
shit?
I got a point to get to, guys.
We'll get to your
Yeah.
point then.
A high
It
number,
has.
Brian.
Do it then.
A high number. A high number, Brian.
May I answer? Because you guys didn't let me answer what is.
All right, let me finish with this. It'll never happen,
just
guys.
gives
You'll never break
Go
windows.
ahead, but we'll never get
Hold
this
on,
thing
Brian.
back.
You don't listen to me, huh, Brian? Trying to speak.
Go ahead,
Okay,
Silent
man.
Zero.
I tried to make a conclusion.
sorry,
I
that
was
was
very
silent.
short one, but I was unable to.
All I want to say is
flat earthers talk.
there's no force on
Who
the
don't?
air pushing back. What you're doing, you're gathering the air. When you move forward, the car, you're gathering the whole of the air, like all the air that is in the cabin, you're gathering on the back because you're accelerating. So therefore you're making it the air more denser on the back. It's gonna
More
push
dense.
the balloon to the front. It's really simple. There's no forces in the air or
Can a
anything
flat
like
earther
that.
correct him?
There is no.
He's not wrong.
I would
Earlier,
disagree. I would say that
earlier
there's,
somebody,
you know,
earlier
a force
somebody
that you
said
can
that.
calculate.
Yeah, in that example, whenever you're accelerating forward, there's not really a force pushing you backwards. The car's pushing forward, and you're keeping you're maintaining your momentum from what you had before, and you're pushing
called
against the back of the
inertia.
car because
That's
the car
right.
is moving forward.
60
pushing forward
miles per
on you.
hour
If
is
we're gonna
not
be
an
pedantic like
acceleration,
that,
though.
if we're gonna be
when the
pedantic
person
like
is
that,
moving,
that's fine. But
the person is
colloquially,
moving.
if I'm being pushed
Then
back
somebody said
when I'm
you're wrong.
accelerating in a car and I feel being pushed back, I'm gonna call that a force all day long. But if we're gonna be pedantic,
Let me
I
tell
just
y'all
need
my
a heads
point,
up,
dude.
that's all.
This is a killer. This is a killer, guys. If I accelerate air forward, if I accelerate the air in a car forward,
Oh, stop
and the
screaming.
helium balloon goes forward, let me finish. And the helium balloon goes forward.
It wouldn't.
And if air is
Yo,
accelerating,
listen.
let me finish.
Accelerating the air forward,
Hold on,
the
guys.
helium
Damn it.
balloon would
If
go
air,
backwards.
hold on, dude. If air in the atmosphere is accelerating downwards, then the helium balloon would go down. Because if I accelerate air in a car forward, the helium forward. Your whole
I have a
model
better
falls
one.
apart.
I have a better one.
Going forward, the helium balloon go backwards.
I can explain that. I can explain that to Brian. The reason why the balloons go up is because the air is accelerated down by
Brenda, I
gravity.
just ran over your
By
shoe. Yeah, I
gravity.
just ran over your shoe in the
Well,
60
why
mile
don't
an
that
hour.
happen in the car then?
Idea. So, hey, Brenda.
Wow, you just ran over his shoe and then you ate it.
Hey, Aaron. Can
I
I
explained it.
I have a,
Hey, Eyes, what's up?
hey, I just have a little question. So, feeling that force in the car against your body, wouldn't that just be because of the change in acceleration? Not
Well, it's acceleration. It's a change in
Eyes.
speed or change in
Eyes.
velocity.
Here's what we're talking
But it would
about.
just
Because you're in the
just be
reference
called
frame of the
acceleration.
car.
Right.
Because
Eyes.
you're in the reference frame of the car, and you
Eyes.
feel the force
Here's what we're
backwards,
talking
right?
about, though. Eyes is 60 miles per hour an
Oh, shut up.
acceleration.
We get
Is
like
that
5 steps
acceleration?
forward and Aaron
No,
brings us
no
Per
one's
hour,
talking
per hour,
about
that's
that.
squaring it. You
You don't square
Yes.
it. It's just per
Yo,
hour.
eyes, you
well,
can,
you
you
do
can hop
square
in
it.
my car and you can feel the force.
It's
in your body.
distance.
So percentages
me
are fucking
give you-
weirdo
let me
now
give you
too.
this one. Let me
Add
give you
that
this
to
one,
add
Eyes.
that to
Let me
the
give you this
equation.
one. Eyes, let me give you this one. So an inch
Brandon,
right?
permission to
Plus you
turn
have wind
Aaron
resistance.
down.
Also, that is,
Aaron,
somebody asked that.
I
Is
muted
is
you.
there anything pushing on the front of the car?
Thank
It
you
was
so
me
much.
that
You are
muted
right.
you. All right, go
You
ahead.
are right to a certain extent. Yes, it's just going to be acceleration or deceleration, and then you would say it change in velocity. That's how you would specify it.
Yeah, they say that if the Earth were to slam on
Hi,
brakes, we'd
Brandon.
fly off at 1,000 miles an hour. If we flew off the Earth that slammed on brakes at 1,000 miles an hour straight out, don't you think we'd feel it?
Yeah, you'd be if you were going 200 miles per hour in a car. If there's nobody in the car going 200 miles per hour and it stopped instantly, it stopped immediately somehow, then the air in the car could break the window.
Well, you would be marinara sauce too.
But the argument to
There's
that,
no
Brian, is
Hello,
that the
guys.
Earth isn't going to stop turning all of a sudden, so you won't feel it.
So you're saying the air's not bonded then? The air's not bonded to nothing then?
It's irrelevant. It still has
Okay.
mass
Yeah,
and
no,
it's
you talked
affected by
about air
gravity.
perfectly. Right, so the air's not bonded at all. It's just,
No,
it just goes
it's
wherever,
irrelevant.
right?
It's irrelevant. Air has mass.
May I please say something really quick? When you guys were talking
Let
about
him
like
answer my question. Let him answer my question. So the air's not bonded to nothing, right?
Is it relevant? That's the answer.
forever,
yeah,
you keep speaking forever and never let anybody else talk. So here's the deal: if I'm traveling in a constant rate of 10 miles per hour, and then in the next hour, I speed up to 70 miles an hour, I've just increased my velocity by 60 miles. Now in the next hour, if I speed up to 130, you could say from the point in time where I started at 10 to the end of the time where I ended
Yeah,
at
60 miles per
130.
second per hour per hour. Yeah.
60 miles per hour. because I've increased my
accelerating.
velocity by 60 miles per hour every hour.
Somebody already
That's pretty
told him
good,
that
Chris.
3 times though.
Yeah, he's
I
muted
know.
right
That's
now,
a
so
very
let's not
simple example
let's not get
of
into
what
it.
it
That's all
means.
linear though.
I'm
No,
glad we
what they
went
tell us
through-
on
I'm glad
Earth
we
is
did
that
it
we
again.
upward. We're not talking about linear velocity, guys. If linear velocity is right, she said if you're going in a car 200 miles an hour, you slammed on brakes. And no, what they're saying is if we're on Earth and the Earth is spinning, they say we'd fly up at 1,000 miles an hour, not the direction we're fucking spinning. They say we
No.
would fly up.
Your tangential
I didn't even know.
direction.
Yeah, you
It's
fly.
always
Yeah, you fly
tangential
perpendicular
velocity.
to it.
Yeah, you would
Right.
fly straight
You fly
across the
off the
ground.
surface of
Wow.
the. You assumed up when they said off the surface of the planet. You just assumed up, but that's just not really. You would fly tangential until
Dude,
you
you
were
can
going
do the math,
basically
dude.
up.
Do the math.
You're confusing
Do the
you're
rim.
confusing the
Do the
different
rim
reference
velocity.
frames, Brian.
Brian,
You're
I never
confusing being on the
specified-
Earth rotating versus someone who's outside the Earth's rotation. They're two different reference frames. You need to get them straight.
I just want to make my point that I never described what I was driving on. Well,
Thank you.
for example, that would still hold true if I was traveling on a racetrack doing the same thing. You don't have to be going straight. My
Bro,
velocity.
Lale, the
can
only
increase
person
by
you're
60
arguing
miles
against
per hour
is muted.
per
He's
hour.
muted.
The only
Lale,
person
he's
that has a
muted,
different
man, and we don't want to
opinion
invoke
is
him.
muted. Yeah, it's all right.
Yeah,
we're
we're
not
all
trying
on
to
board,
invoke
Lale.
him. Give him a reason to be
He's-
unmuted right now.
He's
I'm
speechless,
on
Lale.
board.
You dumbfounded him.
that's a good way to put it.
Anyway,
Anyway, I'm
guys,
just trying to
well,
get your
there's a
bottom
lull,
line.
so let me read this.
Sorry.
James Mays had a question for Rumpus. Unfortunately, I had to mute Rumpus too. It says, Rumpus, explain the clouds for the audience. Where is gravity when it comes to the clouds?
Clouds are easy to explain. They're
Yeah,
little droplets of water.
Yeah.
Yeah.
They're neutrally buoyant.
Dustin water.
I don't know.
Dustin water.
I've seen one look like a lion before, so I don't know about this whole water droplet bullshit.
Each little
most of them are telling
droplet
the
is
truth.
light enough. Each little droplet is light enough to be held up in the air by all the winds that are around.
Actually,
And it's
water
got a
is actually
charge.
lighter than air, right?
Well, the
water vapor.
Yeah, water vapor.
There are winds.
Brenda,
There are winds. There are winds.
Right. Just like when you're boiling water and you have the water vapor come up as steam, or you have the steam come up,
Brenda,
it has a lot of energy in it to do that.
Yeah,
That's
I don't
what
think
it
that was a
is.
good answer, Brenda. A better answer would be that the vapor is lighter than air, but as it goes up, it cools down, it condenses water, and it reaches a point of stasis, basically, until it falls down again.
Yeah.
Brenda, what you
Or
said doesn't make sense because I've seen a cloud that looks like an elephant, and we all know elephants weigh a whole lot. So how can an elephant sit in the air?
You got video proof? Otherwise, we don't believe you, Lale.
Dennis Leary did it.
Dumbo.
Yeah. Or elephant, what is it? Elephant Dumbo drop?
Sorry, I just wanted to troll Brenda.
Yeah, it's okay. So the clouds stay up in the air for the same reason that an aircraft carrier stays up on the water.
Yeah, relative density. Thank you.
Yeah, then if you heat the water, it loses moisture, right? And then if you evaporate the whole ocean, it's going to be sitting on the ground. It all works in nature. It's all balanced. It's all balanced. It's all easily demonstratable. Okay, nobody argues. Nobody argues with acceleration part of it.
On the water because of how much
That's my main
water
point.
they displace.
How does a ship
Love you all.
floating? How does relative density accommodate a ship floating?
Something floating
Okay, it
and
doesn't
something
matter.
floating is
Boys,
not as
it
dense
doesn't
in the
matter,
water.
guys. Okay, if you put
Archimedes
hydrogen
principle.
in the middle of the mountain, if you put hydrogen in the middle of a mountain, it's not displacing the fucking mountain. It's still going to try and seep its way through to go up. Okay, it's all due to
It depends if the hydrogen explodes or not. If the hydrogen explodes, it will displace the mountain.
How does relative density explain a ship floating?
We just told you, bro. It's
it's-
less dense
it's-
than the water.
That doesn't explain anything. You're just
Yes, it does.
restating. No, it doesn't. You're just
It's
restating it.
Archimedes' principle. It's Archimedes' principle.
Principle doesn't talk about no density.
Yeah, it's Archimedes' principle.
It does.
You
It's
nailed
the
it.
density of the
does.
fluid versus the density.
Doesn't
of
really
the
doesn't explain. Yeah,
It is.
that's
Go
a good
look it
example.
up, silly.
Gleam, you don't know anything about physics. Stop pretending that you do.
Ellen, go ahead and recite what Archimedes' principle is.
So the reason
You know
that
more
ships,
too, to these women.
so the reason ships float is because the water around them is pushing them up.
Oh, this Brenda, you are so retarded.
God damn.
I know. The reason that's called buoyancy, right? There's a buoyant force that is applied to the hull of the ship that keeps it afloat.
So when we get to the bottom, so the water should push it down when we get toward the bottom, right? Because there's barely any water below it. So the water should displace the air down.
Wait, there's
because-
barely any water below the ship? There's tons of water below the ship. What are you talking about? There's a whole
If you take
ocean of
the air,
water.
if you take the air,
There's
you're
a
going to
whole
call it
ocean of
simply
water
due to
below the ship.
displacement. If you take a ping pong ball and you get it right there at the bottom of the ocean, okay, and you just sink it halfway in the sand, okay, it's not displacing water underneath it. The only water it's displacing is above it. Does it pin it to the surface due to gravity?
It would go to the surface because of buoyancy.
Does it pin it to the ground? Right. And so you're saying displacement. Okay, well, I just gave you an example of where only half of it's displacing. Only the top half is only displacing the top half, but is it getting pinned to the ground? I mean, is it getting pinned to the bottom due to gravity?
It's because of buoyancy. There's a buoyant force on the ping pong ball.
Yeah,
Right,
the reason it only displaces half of it is only going to displace the amount of the weight of the force that's pushing up on it is going to be equal to the volume that it's displacing of the weight of the medium that it's in. So the medium of the water, the amount that it's displacing in the ship or whatever, it's only going to be able to displace whatever the weight is that's equal to that of the same density of the water.
What dictates its direction? Its density, right?
No.
The pressure gradient in the water.
You just said no. You just said no that the density does not
The pressure gradient in the water dictates the
Bro,
direction.
you were born with a blemish, bro.
The
No, it's the
pressure gradient in the water determines the direction, guys.
That
This is why
correct.
when you accelerate a fluid, it changes the direction of the buoyant force, like we talked about in the car.
Yes, and on the bottom of the ocean, there's still a density gradient.
Okay, it's about that time at 8 o'clock. Hope you enjoyed. That was I don't know, it's one of those nights where everybody wanted to talk all at the same time. So I guess maybe I'm not a great moderator sometimes, but it gets a little frustrating sometimes. James, thank you very much for the super chats tonight. And Carlos 888, happy birthday. Emma, thanks for the super chat. JQ and Good Servant, thank you guys. And we will see you on Friday. Actually, I have a funeral to go to tomorrow, unfortunately. But we'll be back on Friday night fights. And yeah, that should be fun. Anyway, thanks for watching. Thanks for listening. And we'll see you guys tomorrow or Friday. Bye.
The Earth is very flat.
I forgot to mention Gordzilla. Gordzilla had a super chat early too. Thank you, Gordzilla. It didn't show on the screen, but I saw your name and reminded. I didn't want to forget. Thanks, man.